Hello there and welcome to Just About Earth. Where curiosity slows down, the planet gets a little quieter, and science takes the long road through the dark, preferably with comfortable socks and no urgent appointments. Tonight, we are travelling to a place where an entire lost world was not found in a single, dramatic flash, not by someone brushing sand away from a golden doorway or pulling a mysterious lever in a forgotten temple, although that would have been wonderfully convenient. It was found in stone, layer by layer, tooth by tooth, bone by bone, in the dry northwest of Queensland, Australia, where the land today can look sunlit, open and rugged, but where the rocks hold memories of rainforests, lakes, caves, predators, climbers, swimmers, flyers, and creatures so strange that they seem to have wandered in from a dream that evolution had and then forgot to explain properly. This place is Riversleigh, part of the Australian Fossil Mammal Site's World Heritage Property, paired with Narracourt in South Australia, and recognised for preserving some of the most important evidence of how Australia's remarkable animals evolved through deep time. UNESCO describes Riversleigh and Narracourt as among the world's great fossil sites, with Riversleigh especially important for showing key stages in the evolution of Australia's unique fauna. Before we wander any farther into this fossil landscape, I'd love to know where in the world you are listening from tonight. Are you somewhere warm, with a window open, and the evening insects making their tiny mechanical music? Are you somewhere cold, tucked under blankets while the rest of the house gets still? Or are you in that mysterious in-between state where you meant to go to bed early, looked at the time, and discovered that time had apparently wandered off without supervision? And since tonight's journey is about a lost world hidden inside an ancient landscape, tell me, if you like, what is the oldest place you have ever visited? A cliff, a cave, a desert, an old forest, a museum hall where the skeletons looked a little too patient. There is something calming about remembering that the ground beneath us has been busy for a very long time, whether or not we remember to answer our emails. And if you find this gentle journey soothing, curious, or just a pleasant way to let your thoughts settle, at the end of the day, I'd be very grateful if you gave the video a like and maybe subscribed. It helps this little corner of quiet science reach others who might also enjoy drifting through ancient worlds at a pace that does not require hiking boots, sunscreen, or being chased by an extinct carnivorous marsupial. That last part is especially important. There are many kinds of relaxation, but being pursued by a prehistoric predator rarely appears on the sensible list. So, settle in. Let the day loosen its grip a little. Riversleigh is not a place that needs to be rushed. It waited millions of years to be understood, which makes even the slowest bedtime listener look impressively punctual. And unlike many fossil sites, Riversleigh does not tell a story with just one spectacular animal. It is not only a graveyard of bones, it is more like an archive, a library of vanished ecosystems, where each fossil is a sentence and each limestone deposit is a page. Some pages describe forests thick with leaves. Others hint at pools and caves. Some preserve the remains of animals that have no exact modern equivalent, and others reveal ancient relatives of familiar Australian creatures: kangaroos, koalas, possums, bats, crocodiles, turtles, birds and predators that carried their young in pouches while still being very much capable of ruining someone's afternoon. The Riversleigh section is in northwest Queensland, mostly within Boojamula National Park, and is known as one of the richest fossil mammal deposits in Australia. Today, if you visit the region, you do not step into a wet green jungle. You step into an outback landscape shaped by limestone, heat, distance, and the very practical reminder that Australia is not a small place, just because maps politely fold it into the corner of the world. Riversleigh lies hundreds of kilometres northwest of Mount Isa, in a region where travel itself becomes part of the experience. Roads, dust, low vegetation, pale rock and wide skies all give the modern landscape a spare, open feeling. Yet the fossils say that this same area was once very different. Long ago, during parts of the Oligocene and Miocene, roughly tens of millions of years before the present, Riversleigh preserved evidence of habitats that included lush rainforest environments, freshwater systems, and limestone caves where bones could be sealed and protected. The Australian government notes that the Riversleigh deposits are outstanding for their diversity and preservation, helping scientists understand the long history of mammal lineages in Australia. That contrast is what makes Riversleigh feel so quietly astonishing. The place you see and the world the rocks remember do not immediately match. It is a little like opening an old biscuit tin expecting sewing supplies and finding a rainforest inside. The surface seems to say one thing, the fossils say another. They say there were branches overhead, animals moving through shade, water lying in pools and caves forming in limestone. They say there were creatures gliding, climbing, digging, swimming, stalking, feeding, calling, and disappearing into mud or water or darkness, only to be found millions of years later by people patient enough to notice that a small piece of stone could contain the jaw of an animal nobody had ever seen before. The phrase "lost world" can sound dramatic, as though Riversleigh were a hidden valley where ancient animals somehow survived unchanged into modern times, perhaps just beyond the next ridge, politely avoiding cameras. That is not what Riversleigh is. Its creatures are gone. Its ancient forests are gone. The climate shifted, environments changed, lineages rose and vanished, and the Australia we know today gradually replaced an older Australia that would have looked, sounded, and smelled very different. But in another sense, the phrase is exactly right. Riversleigh is a lost world because it preserves not only isolated species but communities. It gives scientists enough evidence to reconstruct relationships between animals and habitats. It does not simply say, here was a jaw, here was a tooth, here was a skull. It says, here was a place where life was complicated. Here were predators and prey. Here were tree dwellers, ground walkers, swimmers, scavengers, and night flyers. Here was an ecosystem doing what ecosystems always do, which is everything at once, with no committee meetings and surprisingly little paperwork. One of the gentle surprises of fossil sites is that they can make absence feel crowded. At first, there is only rock, then someone recognizes a fragment, then more fragments appear. A tooth leads to a jaw leads to a skull suggests a body, a way of feeding, a way of moving. Soon the quiet stone begins to fill with animals. Riversleigh has yielded fossils of mammals, birds, reptiles and other creatures, including many species new to science, and its deposits have been especially important because the bones are often preserved in limestone rather than flattened or destroyed by harsher geological processes. It is the sort of place where paleontologists can find not only the large and impressive animals, the ones that make museum visitors stop mid-step, but also smaller creatures that tell equally important stories. Tiny mammals, bats, frogs, reptiles, animals that might not look spectacular at first glance, but which help reveal the texture of a living world. And bats, in particular, are one of Riversleigh's great gifts. Fossil bats are often difficult to preserve because their bones are delicate, light, and frankly not built with future paleontologists in mind. A bat skeleton seems designed for flight, not for patiently waiting millions of years in stone. Yet Riversleigh has produced extraordinary bat fossils, helping researchers understand ancient bat diversity in Australia. Imagine for a moment a warm, ancient evening above a rainforest pool. The air is thick and soft. Insects move over the water. Small shapes flicker through the dim light, turning sharply, listening with their whole bodies, hunting by sound. Somewhere below, a crocodile waits. Somewhere in the trees, a mammal shifts its weight on a branch. Somewhere nearby, a predator with sharp teeth has decided that the night is open for business. Then, over millions of years, that scene collapses into mineral, silence, and stone. Not gone completely, but translated into a language that takes time to learn. This is part of the reason Riversleigh matters so much. Australia's modern animals already seem unusual to many people, especially if your local wildlife is mostly squirrels and pigeons looking faintly disappointed. Marsupials, monotremes, giant flightless birds of the past, reptiles that have watched geological ages come and go with admirable indifference. All of these belong to a continent with a long history of isolation and experiment. Riversley lets scientists look back into earlier stages of that experiment. The Australian continent separated and drifted. Climates changed. Rainforests expanded and retreated. Animals adapted in ways that sometimes produce familiar forms and sometimes produced creatures that feel almost impossible the first time you hear about them. A marsupial lion, for instance, is not a lion in the African savanna sense. It is a marsupial predator, part of a very different evolutionary story, with its own anatomy, its own ancestry, and its own way of making smaller animals extremely nervous. Riversley has helped reveal ancient relatives of thylacines, koalas, wombats, kangaroos, possums, bandicoots, and other Australian lineages, showing that the roots of modern Australian wildlife reach into worlds very different from the one we see now. The site's fossils span a broad period, often described as covering parts of the Oligocene and Miocene, a time when Australia's environments were changing from wetter forests toward more open and drier habitats in many regions. That is a useful reminder that evolution is not a straight line with a neat arrow and a tidy label at the end. It is more like a long family gathering in which every relative has taken a different route. Some have changed names, some have vanished before dessert, and a few have arrived looking so unusual that everyone politely pretends not to stare. For a bedtime story, fossils might seem like a strange choice. Bones, extinction, ancient predators, and geological time do not immediately sound like the softest pillow. But there is something deeply calming about deep time when it is approached gently. It stretches the room around us. It makes tonight's small worries feel less sharp, not because they do not matter, but because they are held inside a much larger story. Riversley reminds us that the world has changed many times before us. Forests have come and gone, rivers have shifted, animals have appeared, adapted, flourished, and disappeared. The rocks have kept count without hurry. And here we are, late in the sequence, listening to a story made possible because limestone happened to protect the remains of animals that never knew they would one day become evidence. The name Riversley itself belongs to a real place, not a fairy tale kingdom, though it would not be entirely out of place on an old map with a sea monster in the corner. It is located on Wanyi country, and modern descriptions of the area properly recognise its cultural significance as well as its scientific importance. The Queensland government notes that Riversleigh lies within the country of the Wanyi people, and visitor information asks people to respect the special place they are entering. That matters because landscapes are never only scientific objects. They are also lived places, named places, remembered places, and cared for places. A fossil site can be measured, mapped, dated, and described, but it is still part of a larger human and cultural landscape. The discovery of Riversleigh's scientific importance did not mean that an entire world was suddenly understood all at once. That is rarely how science works, despite what dramatic music in documentaries sometimes suggests. More often, science advances by noticing, returning, comparing, arguing politely, arguing less politely, writing papers, revising names, looking again, and discovering that one small bone you thought belonged to one animal may have belonged to something else entirely. Fossil work can be hot, dusty, slow, and uncomfortable. It involves careful collection, preparation, identification, and years of comparison. Some discoveries are spectacular, of course, but many begin as something small in the rock. A tooth, a fragment, a curve that does not look quite like the surrounding stone. Paleontology often depends on trained patience, which is a lovely phrase until you realise it may involve kneeling in the sun for hours while flies conduct an enthusiastic inspection of your face. Still, that patience has changed what we know about ancient Australia. Riversleigh is often described as one of the great fossil fields of the world because it preserves such a wide range of animals, and because those animals help fill gaps in Australia's mammal history. Fossil sites are not all equal in what they can tell us. Some preserve a single moment, some preserve a narrow environment, some preserve mostly hard-shelled creatures, or mostly large bones, or mostly animals that happen to fall into a particular trap. Riversley preserves many deposits across time, giving a broader view. This allows scientists to compare animals from different periods and ask how communities changed. Which species appear? Which vanish? Which lineages continue? What does the changing cast of animals suggest about climate, vegetation, water, and the slow reorganisation of a continent? There is a particular kind of wonder in realising that a fossil is not just a thing. It is a record of a relationship. A tooth tells us about food. A limb bone tells us about movement. Eye sockets can hint at behaviour. A skull can reveal senses, muscle attachments, bite forces, and ancestry. A tiny bat bone can tell us about flight and night hunting. A crocodile fossil can suggest water. A tree-dwelling mammal suggests forest structure. When enough of these clues gather together, the lost world becomes less like a fantasy and more like a scientifically supported reconstruction. Not perfect, not complete, but real enough to walk through in the mind. And what a walk that would be. Not the Riversley of today, with dry rock and open country, but an older Riversley, damp and green in places, with freshwater pools reflecting leaves. You might hear insects first, then frogs, then the movement of small mammals in branches. There could be crocodilians in the water, turtles near the edges, birds moving through the canopy, and mammals unlike anything alive today making their careful way through the undergrowth. Some would look almost familiar and then suddenly not. A kangaroo relative that did not behave like the kangaroo seen today. A possum-like animal that belonged to a branch now gone. A predator with marsupial ancestry but carnivore habits. The ancient Australian rainforest would not have been a gentle petting zoo with better lighting. It was an ecosystem, and ecosystems are beautiful partly because everything in them is trying very sincerely to continue being alive. The title of tonight's journey says they found the remains of an entire lost world, and that is the idea we will keep returning to. Not a lost world in the sense of a place waiting untouched behind a curtain, but a lost world reconstructed from evidence. Riversley is not simply a collection of fossils, it is a way of seeing Australia before the Australia we know. It lets us imagine a continent that carried different forests, different climates, and different animals. It reminds us that modern landscapes are temporary arrangements, not final versions. The outback was not always the outback. The dry country was not always dry. The animals that now seem iconic were once part of longer, stranger family histories. Even the most familiar living creature has ancient relatives somewhere behind it. Some successful, some brief, some deeply odd, as though evolution occasionally stayed up too late and started sketching with unusual confidence. As we begin, it is helpful not to think of Riversley as a single discovery, but as a continuing conversation between stone and science. The rocks do not explain themselves quickly. They do not clear their throats and announce, "Here is the Miocene rainforest section. Please take notes." They wait. People return. New techniques develop. Old fossils are re-examined. New species are described. The lost world becomes clearer, not in one sudden reveal, but in a slow brightening, like a room at dawn. A jaw found decades ago can become important again when compared with a new specimen. A tiny bone can change a family tree. A deposit once thought to represent one kind of environment may become more complex as more evidence appears. This is one reason ancient places remain alive in science. They keep answering, but they also keep asking better questions. So tonight, as the world outside your window continues in its ordinary modern way, traffic, wind, late messages, floorboards cooling, perhaps a refrigerator making that small sound that always seems louder at night, we are going to move backward into a much older Australia. We will not rush there. Riversley did not hurry to become stone, and we do not need to hurry to understand it. We will begin with the landscape itself, Because before there were fossils, before there were museum drawers and scientific names, before there were papers and field notes, there was a living place. There was climate, water, vegetation, limestone, animals, and the ordinary daily business of survival. And if we want to understand how the remains of a lost world could be found in the first place, we need to let that world become real for a while. Not as a fantasy, but as a past environment that once held breathing bodies, warm evenings, wet ground, and the quiet tension of life going on without any idea that one day it would be remembered. Long before the sun-baked limestone of Riversley became a place of field hats, fossil trays, careful labels, and paleontologists crouching over rock with the patience of people who have accepted that flies are simply part of the research team, Northern Australia was a very different country. Not a different country on a map, of course. The continent was still Australia, though it was moving, changing, warming, drying, and slowly becoming the place we recognise today. But the Riversleigh world preserved in the rocks belonged to an older Australia, one where parts of the north were wetter, greener, and more enclosed than the open landscapes we often picture now. The Queensland government describes ancient Riversley as once being a lush rainforest landscape scattered with lime-rich freshwater pools, with fossils from the Oligocene to Miocene, roughly 30 to 10 million years ago. So if you were somehow able to stand there then, after taking the necessary precautions against stepping on something with far too many teeth, you would not be looking across the same dry country visitors see today. You might instead find yourself under heavy shade, with damp ground beneath you, water nearby, leaves above you, and a living crowd of animals going about their business with absolutely no concern for how confusing they would one day become to scientists. It is worth pausing with that image for a while because it can be difficult to let the modern landscape and the ancient one sit together in the mind. Today, Riversleigh lies in northwest Queensland, in the Boojamoola region, within a place known for dry country, limestone, distance, and hard light. The Riversleigh section is part of the Australian Fossil Mammal Sites World Heritage Property, along with Narra Coorte in South Australia, and UNESCO recognises it for exceptional fossil mammal assemblages from the Oligocene to Miocene, spanning about 10 to 30 million years ago. But those rocks are not simply old shelves holding old bones. They are evidence of a vanished setting, a place where water and limestone work together, where animals lived around pools, where caves and crevices formed, and where the conditions were sometimes just right for remains to be sealed away. If the modern land is the book cover, the fossils are the pages inside, and the story they tell is much greener than you might expect. Imagine arriving not by road, not in a four-wheel drive, not with a water bottle and a sensible hat, but as a small animal in the ancient forest. The air would feel different. Warmer perhaps, depending on the exact time and place, but also heavier with moisture. Leaves would interrupt the sky. The ground would be uneven with roots, fallen branches, wet patches, limestone edges, and the small disturbances made by creatures that had passed only minutes before. A pool might lie in a hollow, fed by mineral-rich water. Insects would skim the surface. Frogs might call from the edges, not in one neat chorus, but in overlapping signals, each one insisting that its tiny message was very important. Above, bats could flicker in the dimness, and small mammals might move through branches with the careful confidence of animals that know the forest in 3 dimensions. Somewhere lower down, something else might be waiting. In any rainforest, shade is not just shade. It is shelter, hunting cover, sleeping space, nesting space, and occasionally a very good place for something to watch you without making a sound. The strange thing about ancient ecosystems is that they can be both familiar and deeply unfamiliar at the same time. A rainforest is easy enough to picture. Most of us can imagine damp leaves, trunks, shadows, water, insects, and the green smell of growth. But Riversleigh's rainforest was not simply a modern rainforest moved backward in time. It held animals from Australian lineages, some related to living groups, and others belonging to branches that have disappeared. There were mammals, birds, reptiles, amphibians, and other forms of life interacting in ways we can only partly reconstruct. The fossil deposits of Riversleigh have produced ancient mammals, birds, and reptiles, and the area is often described as the richest known fossil mammal deposit in Australia. So when we picture this old forest, we should not fill it only with modern kangaroos, koalas, possums, and crocodiles in slightly older costumes, as though evolution had simply invited them to a themed party. Many of these animals were different. Some belonged near the roots of familiar family trees. Others were side branches, experiments, specialists, survivors for a time, and then names in stone. The forest would have had layers. That is one of the important things to understand about any closed, wet habitat. Life does not simply sit on the ground waiting to be counted. It stacks itself. There are animals in the leaf litter, animals in burrows, animals on trunks, animals in hollows, animals in the canopy, animals in pools, animals at the water's edge, and animals that move between all of these spaces depending on hunger, weather, safety, and opportunity. A small insect-eating mammal might hunt under fallen leaves. A larger browsing animal might feed on soft vegetation. A reptile might bask where a gap in the canopy allowed a little sunlight to reach stone. Bats might roost in caves or trees and emerge when the light thinned. Birds might move through the branches, some calling, some quiet, some waiting for insects to make a mistake. The rainforest was not a painting. It was an arrangement of routines, interruptions, escapes, meals, births, injuries, smells, calls, and small decisions. Very few animals in the ancient forest were thinking about the future, which is probably a healthy approach if your main plan for the afternoon is not being eaten. The limestone pools are especially important to this story. Riversleigh's fossils are closely connected with freshwater limestone deposits, and the preservation there is unusual because many remains kept their three-dimensional form rather than being flattened beyond recognition. That detail sounds technical, but it matters. Fossils are not always generous. Sometimes they preserve only outlines or fragments. Sometimes pressure crushes bones into shapes that make scientists sigh quietly and reach for more coffee. But Riversleigh often preserved skulls, jaws, teeth, and bones in ways that allow researchers to study anatomy in great detail. That is one reason the Lost World can be reconstructed with such richness. A flattened smear can tell you something. A well-preserved skull can tell you much more. It can suggest how an animal fed, how strong its bite may have been, where muscles attached, how its senses were arranged, and how it might relate to other species. A skull is not a full biography, but it is much better than a vague rumour. In those ancient pools, water was not simply background scenery. It shaped who came close, who lingered, who hunted, and who died. Water draws life. It draws drinkers, swimmers, insects, amphibians, reptiles, and predators that have noticed the first group. It also creates hazards. Edges can be slippery. Mud can hold small bodies. Floods can move remains. Mineral-rich water can begin chemical processes that help preserve bones. The same pool that supports life can become, under the right conditions, part of a fossil-making machine. It is not sentimental about the matter. Nature rarely is. A pool does not decide to preserve a world for future museums. It simply exists, gathers minerals, receives leaves, bones, silt, and time, and later people arrive and give it significance. This is one of those quietly humbling facts about paleontology. The archive was not made for us. We are very late readers. Because Riversleigh covered such a span of time, we should not imagine one frozen scene. It was not the same forest for 20 million years, unchanged except for the occasional dramatic entrance by a new animal with unusual teeth. The environment shifted, climate patterns altered, rainforest habitats expanded, retreated, opened, closed, and changed in composition. Over long periods, Australia as a continent moved northward after its separation from other Gondwanan land masses, and many Australian environments became drier. Riversley helps record part of this transition, from wetter forested habitats toward more open and drier conditions in later periods. That means the phrase ancient rainforest is useful, but it is also a starting point rather than the whole answer. Riversley is important partly because it preserves change. It gives us a series of windows, not one postcard. Still, let us stay for now in the wetter world. It is evening. The forest is becoming busy in a different way. Day animals settle, night animals begin. A small mammal clings to a branch, adjusting its grip. Another moves lower, testing the air. A frog stops calling for just long enough to avoid becoming something else's dinner, which is one of the more practical uses of silence. A bat leaves a roost and begins to hunt, its body built for quick turns and delicate corrections. In the water, a ripple spreads. It could be a fish, or a turtle, or something with eyes just above the surface. The animals do not know they are part of a future world heritage story. They do not know that one day their teeth may be named, measured, compared, photographed, and placed into arguments about evolution. They are not ancient to themselves. They are simply alive. That is an important point, and a strangely comforting one. The past was once present. These animals did not live in sepia tone. The leaves were not faded. The water was not symbolic. The ground was not waiting to become a fossil bed. Everything was immediate. Hunger was immediate. Rest was immediate. The need to avoid predators was extremely immediate. A young animal calling for its mother did not know it belonged to a lineage. A predator moving through shade did not know it represented an ecological role. A small creature falling into a crevice did not know it might become part of a scientific record millions of years later. It is only from our distance that the scene becomes deep time. For them it was Tuesday, or the ancient rainforest equivalent of Tuesday, which probably involved fewer emails and more biting insects. Some of the shadows in this forest belong to animals that seem almost gentle at first. Browsers, climbers, small insectivores, creatures that fed on leaves, fruit, soft plants or invertebrates. The Australian Museum describes the Riversleigh forest beast, for example, as a sheep-sized browsing marsupial that lived around 24 to 16 million years ago and fed on leaves, stems, and other soft parts of rainforest plants. That description gives us a useful glimpse of the forest's daily pace. Not every ancient animal was a monster with a theatrical nickname. Many were simply trying to eat plants in peace, which is a respectable life goal. But even a browsing animal tells a larger story. It suggests vegetation. It suggests food availability. It suggests a habitat capable of supporting animals that relied on soft plant material. It reminds us that ecosystems are built as much by quiet feeding as by dramatic hunting. And then, of course, there were the less peaceful shadows. Ancient Australia had predators of its own, and Riversley has helped reveal some of their history. There were thylacine relatives, carnivorous marsupials, crocodilians, snakes and birds of prey. Some predators moved on land. Some waited near water. Some may have climbed or ambushed. The exact mix changed through time, but the old forest was not safe in the storybook sense. It was alive, which is better and more honest. Predation is not an evil added to nature. It is one of the ways energy moves. That may be a soothing idea only if you're not currently the prey animal, but from the calm distance of a bedtime science video, we can acknowledge that the ancient rainforest was shaped by feeding relationships. The presence of predators affects how other animals move, where they rest, when they drink, and how alert they must be. Even a shadow can change behaviour if it might contain teeth. In a dense forest, sight is only one way of knowing the world. Sound matters, smell matters, touch matters, vibrations matter. A modern person walking through such a place would likely feel half-informed, noticing the obvious and missing the important. But the animals of Riversley's old forests would have read their surroundings fluently. A slight movement in leaves, a scent on bark, the call of another animal stopping too suddenly, the splash that means nothing or the splash that means move now. Bats would navigate by sound. Reptiles would rely on heat, smell, sight, and patience. Mammals would combine senses in ways suited to their bodies and habits. The forest at night was not dark to everything. It was full of information, just not all of it written for human senses. Because the fossil record preserves hard parts better than soft ones, there are limits to what we can know. We can find teeth, jaws, bones, and sometimes hints of diet, movement, and relationship. We cannot usually recover the exact pattern of fur, the colour of eyes, the small everyday sounds, the smell of wet bark, or the full behaviour of an animal as it moved through its world. That can feel frustrating, but it is also where careful science becomes more interesting than guesswork. Researchers do not simply invent a rainforest and place animals in it because it sounds nice. They use anatomy, geology, comparisons with living relatives, sediment, site context, and repeated evidence across deposits. A tooth shape can suggest whether an animal cut meat, crushed insects, or processed leaves. Limb bones can suggest climbing, leaping, digging, or walking. The presence of aquatic animals can point toward water. The presence of many forest-adapted creatures can support the idea of closed habitat. Piece by piece, the lost forest becomes less like a dream and more like a reconstruction with evidence holding it upright. Riversleigh's rainforest also sits inside the larger story of Australia's isolation. After Australia separated from Antarctica and continued drifting north, its animals evolved in increasing isolation for long stretches of time. Isolation does not mean nothing enters or leaves forever, but it does mean that lineages can develop in distinctive directions. Marsupials, in particular, diversified in ways that produced an extraordinary range of forms. Some climbed, some grazed, some browsed, some glided, some hunted, some became large, some remained small enough to vanish into leaves. The Riversleigh record gives scientists a look at this diversification before many modern ecosystems had taken their present shape. It shows not just what animals existed, but how different Australia's living communities once were. The modern continent is remarkable, but it is not the only version Australia has worn. A useful way to imagine Riversley is as a crowded old neighbourhood where the buildings have mostly vanished, but the foundations remain. You cannot see the full street, you cannot hear the voices. But if enough foundations survive, you can work out where homes stood, where people moved, where water flowed, where paths crossed. Fossils do something similar for ancient life. They are not the living forest, but they mark its structure. A bat fossil hints at night air and roosting places. A crocodilian fossil hints at water and ambush. A browsing marsupial hints at vegetation. A predator's tooth hints at prey. A frog hints at moisture. Each fossil is small on its own, but together they begin to crowd the silence. The phrase, rainforest of strange shadows, fits Riversleigh, because shadow is exactly where so much of this older life seems to live in our imagination. Not clearly lit like modern animals in a wildlife film, but partly visible. A jaw here, a skull there, a limb bone, a tooth, a scientific name, a comparison to something alive now but not quite the same. The strangeness does not come from fantasy. It comes from genuine evolutionary distance. These were real animals, shaped by real habitats, but many belong to combinations of traits we do not see today. A marsupial predator fills a role we might associate elsewhere with placental carnivores. A browsing diprotodontoid may remind us distantly of wombats or koalas, but it was not either in the modern sense. Ancient koala relatives at Riversleigh show that even an animal we now associate so strongly with eucalyptus forests has a deeper history connected to older, wetter environments. The Australian Museum notes that fossil koalas such as Madder koala and Pericoala from the late Oligocene and early Miocene sit close to the stem of the koala family tree. So even the familiar sleepy koala, that modern symbol of eucalyptus commitment, has ancestors and relatives tied to a greener and more complicated past. This makes the ancient rainforest feel less like a lost stage set, and more like a family album with some very surprising relatives. Modern Australian animals did not appear fully formed one morning's stretch and decide to become iconic. They are the surviving tips of older histories. Riversley lets us see some of the branches behind them. It also shows branches that ended. Extinction is often discussed as a dramatic event, but much of it is quieter than that. A population shrinks, a habitat changes, a specialist loses the conditions it needs, a competitor arrives, a climate shifts, a lineage continues somewhere else for a while, then fades. In deep time, disappearance is not always a single curtain falling, it can be a long dimming. Riversley preserved some of the light before it went out, and yet the forest was not thinking about extinction. It was not a tragedy while it was happening. It was a functioning world. Rain fell, plants grew, animals fed, young were born, bodies died, bones entered water, cave, soil, or limestone. Some vanished completely, as most bodies do. A few were preserved by chance and chemistry. That's another calming, slightly humbling truth. The fossil record is not a complete guest list. It is a selective memory. It favours certain environments, certain materials, certain accidents. For every animal we find, countless others left no trace we can read. Riversley is extraordinarily rich, but even there, the living world was larger than the fossil world. The stone gives us a remarkable sample, not the whole crowd. As the climate shifted over millions of years, those rainforest shadows would have changed. Openings may have spread. Dryness may have increased in some intervals. Plant communities would have altered. Animals adapted, moved, or disappeared. Some lineages that once lived in wetter forests eventually had descendants suited to more open habitats. Others did not make the transition. This is where Riversley becomes more than a beautiful lost world. It becomes evidence of change. The site helps scientists understand how Australian wildlife responded as environments altered over time. That matters today not because the past repeats in a simple way, but because it shows that life and climate have always been connected. Animals are not separate from their habitats. Change the water, the plants, the temperature, the seasonal rhythms, and the animals must respond. Some responses are impressive, some are not enough. For now though, before we follow the story into discovery and the work of reading the stones, it is enough to let the old forest settle around us. Picture the pools in low light. Picture limestone beneath roots. Picture the branch where a small mammal pauses. Picture the ripple at the edge of the water. Picture a bat turning through warm air. Picture a browser tearing soft leaves. Picture a predator waiting in cover. Not evil, just hungry. Around them the forest is dense with ordinary life. Nothing knows it is ancient. Nothing knows it is strange. The world is not lost yet. It is present, detailed, and busy, carrying on under the leaves while minerals gather in water and caves deepen in the limestone nearby. Much later, after the forest changes, after bodies become fossils, after people arrive with questions, names, tools, and notebooks, those same stones will begin to give back pieces of what they kept, and the first clues will seem small at first, almost too small to hold a world. At first, Riversley did not announce itself as one of the great fossil places on Earth. It did not rise from the ground with a convenient sign saying, "Here lies a vanished rainforest full of ancient marsupials, strange crocodiles, delicate bats, and enough unanswered questions to keep paleontologists busy for generations." It was just country, wide and remote, with limestone outcrops, hard light, heat, and the kind of silence that can make a person suddenly very aware of their own footsteps. The fossils were there, of course. They had been there for millions of years, resting inside rock that had once formed around freshwater pools and cave systems, but fossils are not always obvious to the untrained eye. A bone in limestone can look like stone. A tooth can be no larger than a seed. A fragment of skull can sit quietly under the sun, carrying the history of an animal no human being has ever seen alive, and still look, to most passers-by, like a lump that might be best left alone. This is one of the funny things about lost worlds. They do not always hide behind thick vines or locked doors. Sometimes they hide in plain sight, waiting for someone to realise that the ground has been keeping records. The first clues were not the dramatic kind that cinema prefers. No one brushed away dust from a complete skeleton and immediately understood that an entire prehistoric ecosystem had been found. Riversley began speaking in pieces, a bit of jaw, a tooth, a small block of limestone with something inside it. A fossil animal that did not quite fit what was already known. Early fossil mammal material from Riversley was collected in the 1960s, and the importance of the area began to emerge slowly, not as a single discovery, but as a growing suspicion that this landscape contained far more than anyone had expected. Later, beginning in the 1970s, work by Mike Archer, Henk Godthelp, Suzanne Hand, and many other researchers would turn that suspicion into one of the largest and most important paleontological projects in Australia. UNSW notes that Archer, Hand, and their colleagues were among the early pioneers in discovering Riversley's extraordinary new mammal species from the 1970s, with Archer and Godthelp beginning research there in 1976. There is something very human about that beginning. Science often starts not with certainty, but with a raised eyebrow. A geologist notices something odd, a collector brings back a fragment. A scientist compares it with known specimens and finds that it does not sit neatly in any familiar drawer of knowledge. Then the questions begin. What is this? How old is it? Where exactly did it come from? Is there more? And perhaps most important of all, does this single piece belong to an isolated curiosity, or is it the loose thread of a much larger fabric? Riversley turned out to be very much the second kind. Tug gently on one clue, and suddenly the whole ancient landscape began to rustle. The rock itself was part of the reason the site could speak so clearly. Riversley's fossils are preserved in limestone associated with ancient freshwater systems, including pools and caves, and that limestone often protected bones in 3 dimensions instead of crushing them flat. That may sound like a small technical point, but in fossil work it is a little like the difference between receiving a faded postcard and being invited into the room where the photograph was taken. A flattened fossil can still be valuable, but a skull or jaw preserved in its original shape can reveal far more. The shape of the teeth, the curves of the jaw, the openings in the skull, the attachment points for muscles, the structure of the ear region, all of these details help scientists understand what kind of animal they are looking at and how it may have lived. The Australian Museum describes Riversleigh as having more than 250 fossil-rich sites, with hundreds of new species described from thousands of well-preserved specimens, and notes that many more remain undescribed or undiscovered. That number is worth letting settle. More than 250 fossil-rich sites. Not 250 fossils, but fossil-rich sites, each one a small archive with its own history, age, animals, and conditions of preservation. A person could spend a lifetime studying one part of such a place and still have the sense that the stone was holding something back. Riversley is not a single fossil bed like a page torn from a notebook. It is more like a library scattered through limestone, and at first, researchers had to learn where the shelves were. Some deposits lay in places where ancient caves had formed. Some represented pools or fissures where bones accumulated. Some were richer than others. Some preserved particular animals especially well. Some were difficult to remove, difficult to prepare, and probably difficult enough to inspire a few quiet conversations with rocks that did not improve the rock's cooperation. Fieldwork in a place like Riversley is not glamorous in the way people sometimes imagine fossil hunting. It is not all wide-brimmed hats at sunset and triumphant shouting over perfect skulls, though one hopes there is at least a little of that now and then. Much of it is heat, dust, careful mapping, carrying equipment, documenting locations, wrapping samples, and trying not to damage the very things you have come so far to find. The fossils are not scattered neatly on the surface like museum objects waiting to be collected. They are locked in limestone. That means blocks may need to be quarried, transported and prepared later in laboratories. UNSW describes teams excavating fossil-rich limestone at Riversley, including quarrying blocks for later work, and emphasises that the preparation of specimens has been unusually difficult, but highly rewarding because of the quality of preservation. One can imagine the early research teams returning from the field not with one spectacular answer, but with loads of limestone full of possible answers. Somewhere inside those blocks were skulls, jaws, teeth, limb bones, tiny bat remains, reptiles, birds, and animals that would eventually receive scientific names. But first they had to be found again, this time indoors. Fossil preparation can be slow, delicate, and frankly unfair to anyone who prefers instant gratification. A block of rock may contain something important, but the preparator has to reveal it without destroying it. Remove too little, and the fossil remains hidden. Remove too much, and a piece of anatomy that survived millions of years may be damaged in a second, which is a level of pressure that makes most ordinary office deadlines seem rather gentle. Riversleigh fossils are often freed from limestone using acid preparation, a method that takes advantage of differences between the rock and the fossil material. It is careful work repeated in stages with protective coatings, rinsing, checking and patience. There is no sensible way to hurry a fossil out of limestone. You cannot simply tell a 20-million-year-old skull that everyone has places to be. It will come out at its own pace or not at all. And yet that slow work produced some extraordinary results. Skulls emerged with details preserved. Teeth appeared sharp enough to tell stories about diet. Tiny bones revealed animals that had once moved through trees, water, leaf litter, and night air. The lost world was not revealed as a mural. It was assembled as a very large and complicated jigsaw puzzle, except many of the pieces belonged to animals nobody had seen before, and some of the puzzle pieces were still inside a rock the size of a suitcase. As the fossils accumulated, Riversley began to change Australian paleontology. Before its record unfolded, many ancient Australian mammal groups were known only from sparse material, or not known from those time periods at all. The Australian Museum notes that Riversley greatly enhanced understanding of the origins, evolution, and history of many Australian vertebrate groups, including ancestors and representatives of kangaroos, bandicoots, wombats, thylacines, koalas, possums, bats, rodents, platypuses, and extinct groups such as diprotodontids and thylacolenids. It also records crocodiles, snakes, lizards, turtles, lungfish, frogs, birds, snails, insects, and other invertebrates. That's not just a list. It is the outline of an ecosystem. It means Riversley was not merely adding a few names to a catalogue. It was giving scientists enough evidence to begin reconstructing communities. Some of the early surprises must have been especially satisfying. Imagine expecting a few fossil mammals and then beginning to find bats. Many bats. With Riversley eventually becoming one of the richest fossil bat records in the world. Imagine realising that ancient thylacine relatives were more diverse than previously known. Before Riversley's record began to unfold, the Australian Museum notes that only one tertiary thylacine species was known, but Riversley's oligo-Miocene faunas revealed different thylacines. That changes the way one sees the recently extinct Tasmanian tiger. It stops being an isolated late survivor and becomes the last visible member of a much deeper and more varied history. The same is true for many other groups. Riversley gives familiar animals a past, and in some cases a surprisingly crowded one. This is when a fossil site begins to speak in a fuller voice. A single fossil says, "This animal existed." A group of fossils says this animal lived alongside others. A sequence of deposits says these animals changed through time. A rich site like Riversleigh says something more complex. Here are the shifting habitats, the experiments, the branches of family trees, the disappearances, the survivals, and the ecological roles that shaped Australian life long before the modern continent took its familiar form. UNESCO describes Riversley's Oligocene to Miocene fossil assemblages spanning roughly 10 to 30 million years ago as exceptional and often unique, documenting changes in habitat from humid lowland rainforest to dry eucalypt forests and woodlands. That is a large statement, but it began with small evidence. The D site helps give visitors a glimpse of that process, because it is one of the first major fossil deposits found at Riversleigh and the only publicly accessible part of the World Heritage Area. Its fossils date to the late Oligocene, about 25 million years ago, and include turtles, fish, snails, crocodiles, lizards, pythons, birds, and many kinds of mammals. That mixture says much more than old bones were here. It says water was here. It says reptiles and mammals shared the same environment. It says there were food webs, not just isolated animals. It says this part of the landscape held enough life, and later enough mineral protection to preserve a dense sample of a vanished world. For anyone walking the track today, it may be tempting to glance at the signs, nod politely and move on. But beneath that simple visitor experience is a long chain of work: field discovery, extraction, laboratory preparation, identification, comparison, publication, protection, and interpretation. A fossil seen on a sign is the tidy end of a very untidy process. What makes Riversleigh especially interesting is that many of its discoveries did not simply fill empty spaces, they changed the shape of the story. There were animals so unusual that they resisted easy classification. The Australian Museum mentions Yalcaparidon, sometimes informally linked with the name Thingodonta, as an animal with a skull and teeth unlike any known marsupial, assigned to its own family. It also describes the Fangaroo, a small herbivorous kangaroo with large canine teeth, and Mechosuchus, a crocodile that may have been able to climb. These are the kinds of fossils that remind us evolution does not produce animals for our convenience. It does not tidy them into categories that make immediate sense. It works with bodies, environments, opportunities, and time, and the result can be wonderfully inconvenient for naming systems. There is a particular pleasure in imagining the reactions as some of these fossils came to light. Not dramatic shouting necessarily, though one hopes there was some. More likely there were moments of close looking, a tooth that should not be shaped that way, a jaw that suggests a diet no one expected, a skull with features that look partly familiar and partly impossible. The scientist turns it under the light, compares it, measures it, checks again, and begins to feel that small internal shift from confusion to discovery. It is not the instant certainty of adventure stories. It is better than that. It is the slow arrival of understanding. Of course, fossils do not speak in complete sentences. They mumble, they hint, they contradict first impressions. A single bone can be misleading. A tooth can be worn, a skull can be distorted, a fragment can belong to a juvenile, an adult, a male, a female, a known species, a new species, or something that makes everybody reach for the reference collection. This is why Riversleigh's richness matters. The more material scientists have, the better they can distinguish patterns from accidents. One jaw may be strange. 10 jaws begin to define an animal. Fossils from different layers can show whether a species persisted, changed, or was replaced. When many groups are preserved together, the story becomes ecological rather than merely anatomical. Riversleigh's growing importance eventually helped lead to World Heritage recognition. In 1994, Riversleigh and Naracoorte were jointly inscribed as the Australian Fossil Mammal Sites. UNESCO recognises them as providing an outstanding fossil record of the evolution of Australia's distinctive mammal fauna, with Riversleigh preserving the older Oligocene to Miocene record, and Naracoorte preserving a more recent Pleistocene story. World Heritage listing may sound like an administrative detail, the sort of thing that comes with committees, documents, and people in sensible shoes, and it does. But it also means the scientific value of a place has become recognised as belonging not only to one region or one country, but to the shared history of life on Earth. Riversleigh's fossils are Australian, deeply so, but the questions they answer are global. How do animals evolve in isolation? How do ecosystems respond to climate change? How do lineages diversify? And how much of the living world is shaped by vanished environments? The recognition also matters because fossil sites are fragile. A fossil field is not like a mountain that can be admired indefinitely from a safe distance. Paleontology is extractive by nature. To study fossils properly, scientists often must remove them from the ground, record their location, and take them to laboratories. UNESCO notes that physical removal of fossils is a major integrity issue for fossil sites, while also recognising that excavation is part of determining scientific value. This creates a careful balance. The site must be protected, but it must also be studied. Fossils left entirely untouched may remain safe in one sense, but silent in another. Fossils removed carelessly may be lost forever, even if someone carries them away. The difference is documentation, expertise, permission, and respect for the place. Respect is especially important because Riversleigh is not only a scientific landscape, it lies within Boojamoola National Park on Wani country, and Queensland Parks describes Boojamoola as Aboriginal land, with living culture of special significance to the Wani people. Visitors are asked to travel lightly, stay on marked tracks, and leave fossils and rocks as they find them. This is not a minor footnote. It reminds us that the landscape has meaning beyond its fossils. The stones contain deep biological history, but the country also holds cultural history, living connections and responsibilities that are not replaced by scientific curiosity. Good science does not require forgetting that. In fact, it is better when it remembers. As Riversleigh's fossils were studied, the site began to reveal not only strange extinct animals, but also clues about living ones. That is one of the more unexpected turns in the story. Paleontology can seem like a science of endings, always dealing with what is gone. But deep history can help conservation by showing where living groups came from, how their habitats changed, and what conditions they may have depended on in the past. UNESCO notes that Riversleigh and Naracoorte help trace the history of mammal lineages in modern Australia and contribute to understanding the conservation status of living mammals and their communities. In other words, old bones can help us think more clearly about living animals. The past is not just a cabinet of curiosities, it is context, and context is exactly what Riversleigh gives in abundance. Without it, modern Australian wildlife can seem almost abrupt, as if the continent simply decided to specialise in pouches, hopping, egg-laying mammals and reptiles with excellent public relations. With Riversleigh, the modern fauna gains depth. Kangaroos have earlier relatives, koalas have rainforest-linked ancestors, thylacines were once more diverse, bats were abundant and varied, crocodiles occupied roles that may surprise us. Some animals that sound like jokes were real, and some animals that sound familiar were not quite what we imagine. The fossil record complicates the story in the best possible way. It turns a flat picture into a long layered history. There is a gentle lesson in how slowly this all happened. Riversleigh began to speak because people kept listening. Not once, not briefly, but across years of fieldwork and decades of study. A fossil found in one season could be prepared later, described much later, and understood more fully only when another fossil appeared from another deposit. Scientific knowledge did not arrive like a curtain lifting. It accumulated like sediment. Each return to the field added material. Each laboratory preparation opened another small window. Each comparison refined the family trees. Each paper adjusted the map of ancient life. It is a patient kind of revelation, which may be why it suits a quiet night so well. And so the first clues in the stone became many clues. Many clues became fossil sites. Fossil sites became a record of changing habitats. Changing habitats became a lost world with its own animals, relationships and surprises. Riversleigh did not simply give up one ancient creature and fall silent. It kept answering, and the more it answered, the more questions it created. What did these animals eat? How did they move? Which ones climbed, swam, glided, burrowed or hunted? Why did some lineages vanish while others led toward living animals? How did rainforest communities shift as Australia dried? What happened at the edges of those changes, where old habitats gave way and new ones began? The stone had begun to speak, but it was not telling a short story. It was beginning a long one, and the next voices to emerge from it would be the creatures themselves, some familiar, some deeply strange, and some so unexpected that they make the ancient rainforest feel less like a background and more like a crowded stage where evolution had been trying out ideas for millions of years. Once the stones began to speak, the first voices that came through were not all gentle ones. Some belonged to quiet animals that browsed on leaves, crept through branches, or nosed along the forest floor for insects and fruit. But others belonged to hunters, heavy walkers, sharp biters, water-edge ambushers, and birds so large that the word bird almost feels too light for them. Riversleigh does not preserve a soft little woodland scene where every animal takes turns drinking from a pool in perfect harmony, while the background music politely swells. It preserves a living world, and living worlds are busy, competitive, and not always kind. They have lullabies, yes, but they also have teeth. And in ancient northern Australia, some of those teeth were arranged in ways that make modern lions and wolves seem, if not ordinary, then at least easier to categorise. One of the most memorable predators from Riversleigh's world was not a lion at all, though it is often called a marsupial lion. That name can be a little misleading, but also hard to resist. These animals were thylacoleo, an extinct family of marsupial carnivores. They were not close relatives of African lions, and they did not belong to the same branch of the mammal family tree as cats. They were Australian marsupials, part of a very different evolutionary experiment, and yet they occupied predatory roles that make the comparison understandable. A creature like Wakaleo vandeluri, known from the Miocene, was dog-sized and one of the larger predators of its time in Australia. With teeth modified for stabbing and cutting, rather than the long canine and carnassial arrangement we associate with many placental carnivores. The Australian Museum describes Wakaleo vandeluri as a dog-sized thylacoleo and one of the largest predators in Australia during the Miocene, smaller than its later Pleistocene relative Thylacoleo, but still powerfully built compared with living marsupial carnivores. That is a useful place to begin, because a marsupial lion forces the mind to slow down and stop reaching for easy comparisons. If you imagine a lion with a pouch, you have gone a little too far in the wrong direction, though it is an understandable mistake and probably a useful warning about why nature should not be assembled from quick mental cutouts. Wakaleo was not a striped cat, not a spotted cat, not a wolf, not a dog, and not a Tasmanian devil inflated to an alarming size. It had its own anatomy, its own ancestry, and its own way of turning meat into dinner. Like other marsupial lions, it had blade-like cheek teeth that could slice. Its front teeth were large and specialised. It seems to have belonged to a group of animals that solved the problem of carnivory in a very Australian way. Evolution, left alone on an isolated continent, does not ask what a predator is supposed to look like. It asks what works. Then it tries something, and if that something works well enough, the forest becomes home to a hunter that no zoo visitor would recognise. Picture the old Riversleigh forest again, but not as a still painting. It is late in the day. The air is thick. The ground is uneven. The trunks and branches break up the light. A small animal pauses near a limestone pool, perhaps to drink, perhaps because it has heard something it cannot identify. Nearby leaves move. It could be wind. It could be another harmless browser. It could be a hunter built low and strong enough to come through the undergrowth without advertising itself. We do not need to turn the scene into a monster story. The animal is not evil. It is simply alive, and to stay alive, it must eat. But from the point of view of anything smaller, softer and distracted, a marsupial lion moving through the forest would not have been a comforting presence. The larger and more famous Thylacoleo carnifex came much later, in the Pleistocene, and is not the central animal of the older Riversleigh rainforest. But Riversleigh gives us earlier members of the thylacolionid story, showing that this unusual predatory family had a deeper history than the final giant form alone. One of the fascinating things about Riversleigh is that it preserves different sizes and stages of these hunters. Not every marsupial lion was huge. Some were smaller, and one early Miocene species from Riversleigh, Microlio attenboroughi, was described as a diminutive marsupial lion. That detail matters because it reminds us that predator families are rarely represented by only their most dramatic member. We tend to remember the biggest one, the strongest one, the animal that would look best beside a museum visitor for scale. But ecosystems also contain small hunters, mid-sized hunters, specialists, opportunists, animals that take insects, lizards, birds, eggs, young mammals, carrion, or whatever the day allows. The food web has more than one sharp edge. Some of Riversleigh's ancient hunters belong to another famous Australian story, the Thylaceners. The recently extinct thylacine, often called the Tasmanian tiger, was the last surviving member of its family, but it was not the only thylacine that ever existed. Riversleigh changed that picture. Before its fossil record developed, very few ancient thylacines were known, but Riversleigh revealed multiple thylacine species from Oligocene and Miocene deposits. The Australian Museum notes that before the Riversleigh record unfolded, only one tertiary thylacine species was known, while different thylacines have since been identified from Riversleigh's Oligo-Miocene faunas. More recently, researchers described 3 new thylacine species from Riversleigh fossils dating to about 25 to 23 million years ago, adding some of the oldest known members of the thylacine family to the story. This changes the emotional shape of the thylacine. Many people think of the Tasmanian tiger as a tragedy of recent extinction, a striped animal filmed in grainy black and white, pacing in a zoo enclosure before vanishing from the modern world. That story matters, but it is the last page of a much longer book. Riversleigh opens earlier pages. It shows that thylacines were once more diverse, with different species occupying ancient Australian environments, long before the final Tasmanian survivor. Some were small. Some may have filled scavenging or predatory roles in wet forests. They were not all the same animal waiting to become the one we recognise from photographs. They were a family, changing through time, sharing the landscape with marsupial lions, crocodiles, birds, reptiles and other mammals. To understand them only by their ending is like judging a long life by the final line of an obituary. The thylacines of Riversleigh also help us think about competition. In a forest with multiple meat-eating mammals, not every hunter could do the same thing in the same way. Some may have hunted smaller prey, some may have scavenged, some may have been more agile, others stronger, others better at processing bone or tough material. The 2024 research on newly described thylacines suggests that these ancient relatives filled varied predatory and scavenging roles, with the largest only about the size of a small dog but still important in the ecosystem. That image is different from the dramatic predator we might expect. Ancient hunters did not have to be enormous to matter. A small dog-sized carnivore in a dense forest could still be a serious presence, especially if you were a lizard, bird, small mammal, or inattentive creature experiencing a very bad afternoon. Then there were the birds. Modern Australia has its share of impressive birds, and some of them already seem as if they remember a time when birds were a little closer to ruling the place. Cassowaries, for example, have that look of quiet, prehistoric disapproval, as though they have just read your behaviour and found it lacking. But the giant birds of ancient Australia, the dromornithids, belong to an extinct group sometimes called mihirungs. They were large, flightless birds, and one of the important species connected with Riversleigh is Dromornis murrayi. Fossils of this bird from Riversleigh are about 26 million years old, and UNSW describes it as a flightless plant-eating species weighing around 250 kilograms, linked to the lineage that eventually produced the even larger Dromornis sturtoni. A 250-kilogram bird is not the sort of bird that lands on a windowsill and cheers up the morning. It is closer in mass to a very large motorcycle that has made unusual life choices, and yet these giant birds were not necessarily predators. Dromornis murrayi is described as plant-eating, which may come as a relief until you picture a bird taller and heavier than most humans moving through the ancient landscape, with a beak designed for serious vegetation work. A herbivore can still be intimidating. Anyone who has seen a large modern cassowary, emu or ostrich knows that plant-eating does not automatically mean cuddly. The ancient forest and its edges would have contained animals that were dangerous simply because they were large, strong, territorial, or unwilling to step politely around smaller mammals with nervous expressions. The presence of giant birds also tells us something about the changing habitats. A very large, flightless bird needs food, space, and a body plan suited to its environment. It does not move like a bat through the canopy, or like a possum along branches. It belongs to the ground. So when we place Dromornis murrayi in the wider Riversley story, we begin to see that ancient northern Australia was not one unbroken, uniform rainforest with no openings, no edges, and no variation. There were likely mosaics: forest, water, clearings, margins, and changing vegetation through time. Large birds could feed and move through parts of this world, while smaller animals occupied the branches, pools, caves, and leaf litter. This is why a fossil site with many different kinds of animals is so useful. A single animal can mislead. A whole community begins to map the landscape. It is tempting to make ancient predators the stars of every scene. They have the teeth, the names, and the museum displays that make children widen their eyes and adults pretend they are not just as impressed. But a predator is only as interesting as the world that supports it. The marsupial lions and thylacines of Riversley existed because there was prey. There were browsers, small mammals, reptiles, birds, eggs, young animals, aquatic creatures, and carrion. There were food chains and food webs, though the web image is better because everything is connected in messy, practical ways. A crocodile may take a mammal near the water. A thylacine may scavenge what another predator leaves. A bird may feed on seeds or fruit and spread plant material. A small carnivore may keep insect or vertebrate populations in check. A large herbivore may shape vegetation by feeding and moving through it. Nothing in the forest is only itself. Each animal is also pressure on other animals. Crocodilians added another kind of danger. Riversley has produced fossils of crocodiles, including forms that seem very different from the familiar idea of a crocodile as a low, waterbound ambush predator. Some extinct Australian crocodiles, such as mekosuchines, were more terrestrial than modern crocodiles, and the Australian Museum notes that mekosuchus from Riversley may even have been able to climb trees. A tree-climbing crocodile is one of those facts that makes a person pause and reconsider the safety of branches, which are generally meant to be comforting in stories about avoiding things on the ground. We should not imagine every tree in ancient Riversley sagging with crocodiles like over-decorated holiday ornaments. But the existence of more land-adapted and possibly climbing crocodilian forms shows that reptile predators were also experimenting with roles that modern people might not expect. This matters because it breaks another easy assumption. Modern animals often become the templates we use for the past. Crocodiles go in water, big cats go on land, birds fly, unless they are emus. Marsupials carry young in pouches and, in the popular imagination, mostly hop, sleep in trees, or look mildly surprised. Riversley does not obey these tidy boxes. It gives us carnivorous marsupials with slicing teeth, thylacines in multiple forms, crocodiles with more varied habits, giant flightless birds, and many smaller animals filling the gaps between. Ancient ecosystems were not rough drafts of modern ones. They were complete in themselves, using combinations that later disappeared. The snakes and lizards of Riversleigh also belong to that crowded predatory world. Reptiles are sometimes treated as background creatures in fossil stories. perhaps because they lack the immediate emotional pull of a mammal with a face we can imagine more easily. But in a warm, wet, forested environment, reptiles would have mattered. A python in the undergrowth changes how small animals move. A large lizard can be a predator, scavenger, or egg thief. Turtles and crocodiles help mark aquatic habitats. Frogs indicate moisture and provide food for many hunters. Reptiles are not decoration. They are part of the machinery of the ecosystem, though the machinery in this case occasionally swallows things whole. Among the more unusual animals from Riversleigh were not only hunters of the obvious kind, but strange specialists whose habits are still being studied. Some extinct mammals had teeth that suggest diets difficult to compare with living species. Yalkparadon, for example, has often been noted as a particularly odd mammal from Riversleigh and other Australian fossil deposits, so unusual that it has been placed in its own family. The Australian Museum describes it as having a skull and teeth unlike those of any known marsupial. An animal like that does not neatly belong in a sentence about marsupial lions or giant birds, but it belongs in the same world. Its strangeness reminds us that the forgotten Australia preserved at Riversleigh was not simply a familiar ecosystem with a few big predators added for drama. It included forms that challenge our categories from the ground up. For the animals living there, however, nothing was strange. Wakalea was not a strange marsupial lion to itself. A dromornithid was not a giant bird in need of a museum label. A thylacine was not an ancestor of anything in its own mind. Each creature was simply shaped by its body, instincts, environment, and immediate needs. A hunter was hungry. A browser needed leaves. A giant bird needed enough food to maintain a large body. A bat needed night insects. A crocodile needed patience. Even the oddest animal in the fossil record was normal in its own world, which is a helpful thought when we think about deep time. The past becomes strange because we meet it out of context. Riversleigh gives some of that context back. The ancient hunters also raise a question that follows any predator through deep time. How did they hunt? Fossils do not show the chase directly. There is no preserved scene of Wakaleo crouching near a pool, while a small mammal makes a questionable decision. But anatomy gives clues. Cutting teeth suggest meat processing. Limb bones can suggest strength, agility, or climbing ability. Skull shape can suggest bite mechanics. Comparisons with living animals can help, though they must be used carefully. A marsupial lion is not a leopard, but both are carnivorous mammals, and the physics of biting, grappling and slicing are still physics. Scientists can examine where muscles attached, how teeth occluded, how jaws moved, and what stresses bones could withstand. From those details, behaviour begins to emerge, not as a film, but as a set of likely possibilities. For thylacines, the story may have included pursuit, scavenging, opportunistic feeding, and different strategies among species. For marsupial lions, ambush and powerful biting are often discussed for later relatives, though smaller earlier forms may have behaved differently. For crocodilians, ambush from water or movement through land habitats may both have been important depending on the species. For snakes, constriction or venom, depending on the group, would have shaped interactions with prey. The result is not one predator at the top of a simple pyramid, but many hunters operating at different sizes and in different spaces. The canopy had its hunters. The ground had its hunters. The pools had their hunters. Even the night air had bats hunting insects by sound. Riversleigh's ancient world was not safe, but it was balanced in the ordinary way ecosystems balance themselves. Not perfectly, not peacefully, but continuously. The giant birds complicate that balance in another way. Large herbivores can be ecosystem engineers simply by feeding, moving, trampling, and dispersing seeds. A huge, flightless bird feeding on plant material may influence vegetation and create opportunities for smaller animals. Its nests, droppings, movements, and remains could all enter the ecological cycle. And if such a bird died, its body would become a resource for scavengers and predators. In life, It was a consumer of plants. In death, it could feed carnivores, insects, microbes, and eventually perhaps become part of the fossil record. Nothing goes unused for long in a living system. Nature is efficient in a way that is both impressive and slightly rude. Some animals at Riversleigh were probably both hunters and hunted, depending on their age and circumstances. A young carnivorous mammal could be prey for a larger reptile. A small crocodilian could be vulnerable to a large bird or mammal. Eggs could be stolen. Juveniles could be taken. Injured adults could become meals for creatures they once avoided. This is another reason fossil ecosystems resist simple storytelling. The same species can occupy different roles through life. A predator as an adult may have been prey as a juvenile. A scavenger may hunt when it can. A herbivore may defend itself fiercely. The forest was not a set of fixed labels. It was a moving negotiation between bodies. To a modern listener, some of these animals may feel almost too strange to be real. Marsupial lions, tree-climbing crocodiles, giant plant-eating birds, multiple thylacines, odd mammals with teeth that do not match any living marsupial. But that strangeness is precisely what makes Riversleigh so valuable. It shows us that the living world has had many versions, and that our current version is only one arrangement. We often treat modern ecosystems as if they are the standard form of nature. Riversleigh gently corrects that. It says, here is another way a continent once worked. Here are predators you do not have now. Here are birds from a lineage that vanished. Here are mammals that flourished and left no living descendants. Here are ancestors and cousins of animals you know, living in habitats you might not associate with them. Here is the reminder that evolution is not trying to reach the present. The present is just where the process happens to be right now. There's also something grounding about the physical reality of these creatures. They can sound like inventions until you remember the bones. A tooth in a jaw, a skull in limestone, a limb bone with muscle attachments, a beak fragment, a vertebra. These are not myths from the edge of a map. They are remains found, prepared, measured, compared, and published. The lost world of Riversleigh does not depend on imagination alone. Imagination helps us walk through it, but evidence lets us know where to step. Without the fossils, a story about ancient marsupial lions and giant birds might feel like a bedtime fantasy. With the fossils, it becomes natural history. And still, even with evidence, there is room for uncertainty. Scientists continue to revise interpretations as new material appears. A species may be reclassified, a behaviour may be reconsidered. A fossil once thought to belong to one lineage may turn out to belong somewhere else. This is not a weakness, it is how the work stays alive. Riversleigh is not finished speaking. It is still being studied, and the animals we describe now may become better understood later. There are fossils already collected that remain undescribed, and deposits that may yet produce new material. The old forest still has shadows we cannot name. As we let this crowded ancient world move around us, the scene becomes more detailed. In the dim green of an earlier Australia, a small thylacine relative noses along the ground. A marsupial lion waits where cover is thick. A giant bird steps through a clearing, heavy but alert. A crocodilian lies near water, or perhaps somewhere less expected. Bats turn above the pool. Lizards move through warm patches. Birds call and fall silent. Frogs test the air from the edges of water. Browsing mammals feed under the trees, one ear, always available for trouble. None of them know they're part of a fossil site. None of them know that their world will change, that their forests will retreat, that some of their lineages will end while others leave descendants in a drier Australia. They are simply living inside the conditions they have been given. And beneath them, around them, sometimes because of them, limestone is forming. Pools are gathering minerals, caves are waiting, and the processes that will turn bodies into evidence are already quietly in place. If the creatures of ancient Riversleigh gave the lost world its movement, then the land itself gave it a memory. Without the rivers, the pools, the caves, the wet hollows, the limestone, and all the slow chemical work happening beneath leaves and water, those animals would have lived and vanished like most animals do, leaving nothing for us but absence. That is the normal fate of life. A body dies and the world recycles it with great efficiency and very little ceremony. Flesh feeds insects, microbes, scavengers, and soil. Bones scatter, break, dissolve, weather, and disappear. Feathers, skin, fur, cartilage, and soft tissue almost never last. Nature is not generally in the business of keeping neat archives, which is a shame, because it would save paleontologists a great deal of kneeling. For a fossil to form, things have to go unusually right after something has gone rather badly for the animal involved. Riversley matters because, over and over again, the conditions were good enough to interrupt that normal disappearance. Bodies, bones, teeth, shells, and small remains entered settings where minerals, water, and sediment could protect them. The extensive fossil deposits there are encased in limestone formed in lime-rich freshwater pools, and they preserve a record of mammal evolution spanning at least 20 million years. That sounds almost tidy when put into a sentence, but the actual process was not tidy at all. It was a long chain of accidents and conditions: an animal drinking in the wrong place, a bat dying in a cave, a skull washing into a pool, a small mammal falling into a crevice, a flood moving bones, calcium carbonate building around remains, limestone sealing them away, and time doing what time does best, which is continue without asking whether anyone is ready. To understand Riversleigh as a fossil site, it helps to forget the idea that fossils are simply bones that became old. Age alone does not make a fossil. There are countless old bones that are gone completely. Fossilization requires burial, protection, chemistry, and usually a good deal of luck. In many environments, bones are exposed too long. They crack under sun, break apart, are chewed by scavengers, trampled, dissolved by acidic soil, or moved until their original context is lost. In a wet tropical forest, where life and decay are both very active, preservation can be especially difficult. Warmth and moisture are excellent for growth, but also for breakdown. A rainforest is not a museum. It is more like a very busy kitchen where everything is either eating, being eaten, rotting, growing, or trying not to become part of someone else's lunch. The fact that Riversleigh preserved so much from a once lush environment is part of what makes it so remarkable. The ancient landscape was shaped by water. Rivers, streams, pools, and underground flow all mattered. The region contained lime-rich freshwater pools, and the Queensland government describes ancient Riversleigh as a lush rainforest scattered with mineral-rich waters, where fossils from the Oligocene to Miocene, around 10 to 30 million years old, have been uncovered. These pools were not just pleasant places for animals to drink, they were chemical environments. Water flowing through limestone can carry dissolved calcium carbonate. Under the right conditions, that dissolved mineral comes out of solution and forms limestone deposits. If bones or shells are present, they may become coated, encased, or buried. This can protect them from the usual forces that destroy remains. It is a little like the landscape wrapping evidence in stone, although not out of kindness. Limestone has no sentimental feelings about marsupials. It simply forms when conditions allow it. Those lime-rich pools may have looked ordinary to the animals using them. A pond is a pond, after all, when you're thirsty. A small mammal approaching the edge would not have known that the water chemistry was important. A turtle sliding in would not have paused to admire the long-term preservation potential. A crocodile waiting near the surface was probably more interested in movement than mineral deposition. Yet each of those ordinary actions could become part of the fossil story. The pool drew animals together. It concentrated life in one place. Where life is concentrated, death also leaves more material. Some animals died nearby. Some were dragged there. Some fell in. Some were washed in after storms. Some bones may have collected gradually, while others arrived in sudden events. Over time, the water that supported life also helped preserve the remains of life. Caves added another layer to the story. Limestone country often becomes karst country, shaped by dissolution. Water enters cracks, follows weaknesses, widens openings, and gradually creates cavities, fissures, sinkholes, and caves. These features can become natural traps. An animal can fall in and be unable to get out. A predator can use a cave as a den. Owls, carnivores, or other animals may bring prey into shelter and leave bones behind. Bats can roost in large numbers, and their remains may accumulate when individuals die. Small animals can wash into cave systems through openings too narrow for larger scavengers. Once inside, bones may be protected from weather, trampling, and some forms of destruction. Riversley includes fossil deposits associated with caves and freshwater limestone systems, and this combination helped preserve a wide range of mammals, birds, reptiles, amphibians, fish, snails, and other animals. Imagine a limestone cave at the edge of the ancient forest. During the day, it is cooler than the air outside. Water drips somewhere in the dark. The floor is uneven. Small bones lie hidden beneath sediment, leaf litter, mineral crust, and older deposits. Bats gather overhead, shifting and squeaking softly in the gloom. At night they leave, streaming into the forest to hunt insects above pools and between trees. Some return, some do not. Over years, then centuries, then far longer than any individual animal's life could measure, remains accumulate. Guano changes the chemistry. Water enters during wet periods. Sediment washes in. Minerals coat surfaces. Entrances open or close. A chamber that once held living animals becomes sealed. The cave is no longer a shelter. It becomes a container. This is one reason caves can be so important in paleontology. They do not preserve life evenly, but they can preserve it in dense and useful ways. A cave deposit may contain bones from many animals that live nearby, not because all of them chose to die neatly in one place, which would have been very considerate but unlikely, but because the cave collected them. Pitfall traps are especially useful in this sense, though not for the animals. A hole in the ground can be almost invisible under leaves or shadows. A small mammal, reptile, or bird can fall in. If the sides are steep, escape may be impossible. Later, another animal falls in, then another. A predator may be attracted by trapped prey and become trapped itself. Over time, a deposit builds. It is a grim process at the animal level, but at the scientific level, it creates a concentrated sample of a local community. Riversleigh's D site gives one public window into this kind of ancient accumulation. It is one of the first major fossil deposits found at Riversleigh and the only publicly accessible area of the World Heritage Site. Its late Oligocene fossils, about 25 million years old, include turtles, fish, snails, crocodiles, lizards, pythons, birds, and many kinds of mammals. That list tells us that the deposit is not only about land animals wandering through forest. It includes aquatic life, reptiles, birds, and mammals together. It points to water, nearby vegetation, predators, prey, and the mixing of remains from different parts of the environment. A fossil site like that is not a snapshot taken with a camera. It is more like a drawer into which the landscape dropped evidence over time. The making of fossils is often described as a step-by-step process, but in real life those steps blur. An animal dies. The body may lie on the surface, float in water, sink into mud, fall into a cave, or be dragged by another animal. Soft tissue begins to decay quickly. Bones may separate. Teeth, being hard and mineralized, often survive better than other parts. Sediment or mineral crust covers the remains. Groundwater moves through. Minerals enter pores and spaces. Original material may be replaced or strengthened. The surrounding sediment hardens into rock. Later, erosion exposes the fossil-bearing layer, or people cut into the deposit and remove blocks for preparation. Each fossil carries some version of that story, though the details vary. A tooth in a cave and a turtle shell in a pool did not take the same path into the record. The special thing about Riversleigh is not only that fossils formed, but that so many formed with unusually good preservation. Many specimens are three-dimensional, which is a major advantage for understanding animals. If a skull is crushed flat, scientists can still learn from it, but many details are lost or distorted. In Riversleigh's limestone, many bones retain their shape well enough to reveal fine anatomical information. This is why the site has produced such a rich understanding of ancient Australian animals. The State of the Environment report for Queensland describes Riversleigh as one of the world's most significant fossil deposits and the richest known fossil mammal deposit in Australia, with unique prehistoric animals preserved in limestone outcrops. A phrase like richest known fossil mammal deposit can feel distant, but it means drawers and drawers of evidence, many species, many comparisons, and many chances to ask how a whole fauna changed through time. Limestone can be both friend and obstacle. It protects fossils beautifully, but it also hides them stubbornly. When a fossil is encased in hard limestone, removing it is not like brushing dust from a bone in loose sand. The rock must be carefully worked. Blocks may be taken to a laboratory, where preparators use tools, microscopes, and sometimes weak acid to dissolve limestone and free the more resistant fossil material. This is slow work. It is not the sort of thing that rewards impatience. A skull may emerge over weeks, months, or longer. Tiny bones may appear where a block seemed almost featureless. The fossil has already survived millions of years, which is encouraging, but also a little unfair, because one careless modern movement can still damage it. The laboratory becomes the last stage of excavation, and sometimes the most delicate one. It is helpful to picture the fossil record at Riversleigh as something made twice. First, nature made it by trapping, burying, mineralizing, and preserving remains. Then science made it readable by finding, collecting, preparing, comparing, and describing those remains. Without the first process, there would be nothing. Without the second, the fossils would stay mostly silent. A rock containing a skull is not yet knowledge. It becomes knowledge when its context is recorded, its anatomy is studied, and its relationship to other fossils and living animals is examined. That is why the location of a fossil matters so much. A tooth taken without context loses part of its story. A tooth collected with careful notes can be tied to a deposit, a time period, an environment, and other animals found nearby. Fossils are evidence, but context is what turns evidence into history. The ancient pools also helped create what might be called ecological traps, or at least ecological gathering points. In dry or seasonally variable environments, water becomes even more important, but even in wet forests, pools concentrate activity. Animals drink there. Predators hunt there. Dead animals may wash in. Aquatic animals live and die there. If the pool is lime-rich and sediment builds, it can preserve a mixture of remains from water, shore, and surrounding forest. That is one reason a single deposit can include turtles, fish, crocodiles, birds, and mammals together. It does not mean they all lived in exactly the same spot in the same way. It means their remains entered the same preserving system. A fossil assemblage is not the same as a family photograph. It is a gathered record shaped by how bodies moved after death, as much as by where animals lived before death. This is something paleontologists have to think about carefully. The science of taphonomy, which studies what happens to remains between death and discovery, is essential for understanding fossil sites. If a deposit contains many broken bones, were they trampled, transported, crushed by sediment, or chewed by predators? If many animals are found together, did they die in one event or accumulate slowly? If small animals are abundant, were they trapped there, washed in, or brought by predators? If skulls are common but limb bones are rare, what does that mean? Riversleigh's limestone preserves remarkable material, but interpretation still requires caution. A fossil deposit is not a simple census. It is a filtered record, shaped by death, transport, burial, chemistry, erosion, and discovery. The filters can be very strong. Small animals may be preserved in some deposits and absent in others, not because they did not exist, but because conditions were less favourable. Delicate bones usually break or dissolve, but in a protected cave they may survive. Large animals may be easier to notice, but small animals can reveal more about habitat. Teeth are especially useful because they are hard, distinctive, and often diagnostic. A single tooth can sometimes identify a group or species, though it can also start arguments that last for years, which is one of the fossil record's quieter hobbies. The Riversley record includes animals known from abundant specimens, and others known from only very limited remains. That unevenness is normal. Deep time rarely gives equal attention to everyone. As the forest changed, the fossil-making environments also changed. Riversley's deposits span long periods, not one single moment. That means the pools, caves and surrounding habitats were not always the same. Some formed under wetter conditions, others may reflect drier phases, more open habitats, or different animal communities. UNESCO describes Riversleigh as documenting changes from humid lowland rainforest toward drier eucalypt forests and woodlands across the Oligocene and Miocene record. This matters because fossilization is tied to landscape. If water systems shift, if caves open or close, if limestone deposition changes, the kind of record being made also changes. The fossil archive is therefore not only a record of animals, but of the conditions that allowed those animals to be preserved. There is a small danger in imagining fossilization as too smooth, as if a dead animal lies down and gradually becomes a perfect specimen, while the land respectfully leaves it alone. Most fossils are not like that. Bones can be scattered before burial. A skull may be separated from the body. Teeth may fall out. Floodwater may tumble remains together from several animals. Acidic conditions may destroy some parts and preserve others. Roots can disturb deposits. Later geological movement can fracture rock. Erosion can expose fossils but also destroy them before anyone arrives. For every beautiful Riversley skull recovered, many remains must have been lost. The fossil record is generous there, but it is still incomplete. It is not the whole vanished forest. It is what survived the journey. That incompleteness makes the richness even more impressive. Riversley has produced fossils from more than 250 fossil-rich sites, and hundreds of new species have been described from thousands of well-preserved specimens, with many more still undescribed. Think of that for a moment in practical terms. Each site must be located, mapped, sampled, and studied. Each specimen must be prepared and compared. A jaw may belong to a known species, a new species, or an animal whose identity will remain uncertain until more material appears. A fossil from one deposit may become important only after another fossil is found years later. The process resembles listening to a long conversation through a wall, catching more words each time someone opens the door a crack. The caves and pools also help explain why Riversley contains such different animals together. A forest canopy animal, a ground-dwelling mammal, a water creature, and a cave-roosting bat do not all live the same life, but their remains can enter the same fossil system. A bat dies in a cave. A small mammal falls through an opening. A flood carries turtle or fish remains into a low area. A predator drags prey to shelter. A carcass near a pool breaks apart and bones sink into mineral-rich sediment. Later, these remains become part of one deposit or neighbouring deposits. To us, millions of years later, they appear together enough to reconstruct a community. The animals did not gather for our convenience. The landscape gathered them. One of the most useful things Riversley teaches is that preservation is not passive. The landscape was actively shaping the record. Water dissolved and redeposited minerals. Pools formed limestone. Caves trapped remains. Sediment covered bones. Chemistry protected some materials and destroyed others. Erosion later revealed what had been sealed. In this way, Riversley was both habitat and archive. It supported living animals, then preserved a selected record of them. The same limestone that made caves and pools also became the container that allowed the lost world to be studied. That is a neat arrangement, though it took millions of years and involved a great deal of inconvenience for the animals. If we return to the ancient forest, the fossil-making process is happening quietly under ordinary life. A rainstorm passes through. Water runs down trunks, gathers in channels, and carries leaves, soil, and small remains toward a pool. A limestone surface becomes slick. A small animal slips. In a cave, bat droppings accumulate beneath a roost. A predator leaves bones near a shelter. A turtle dies in the shallows. A branch falls and disturbs sediment. A flood rearranges the edge of a pool. None of these events looks important in isolation. Together, repeated over long periods, they build the evidence. This is how a world becomes recoverable. Not by planning to be preserved, but by allowing many small accidents to fall into the right settings. The vanished forest did not vanish all at once. It changed as climates changed, as Australia continued its long movement northward, as rainfall patterns shifted, and as vegetation reorganised. Some pools dried or were buried. Some caves sealed. Some habitats opened. Animals adapted, moved, declined, or disappeared. But the deposits that had already formed remained locked in the rock, holding earlier versions of the world beneath later ones. This layered quality is what allows scientists to compare faunas through time. The site does not say only, here are ancient animals, are ancient. It says, here are ancient animals from different intervals, different conditions, and different stages in Australia's environmental history. That is much more powerful. There's also something quietly strange about the idea that a living forest can become hard limestone. The softest parts of the scene are gone. The leaves, calls, fur, feathers, smells, skin and warmth. What remains is mineral. A pool becomes rock. A cave fill becomes deposit. A skull becomes specimen. The living movement is gone, but the shape remains. A jaw still holds the curve of feeding. A tooth still holds the trace of diet. A limb bone still holds the suggestion of movement. The fossil does not bring the animal back, but it prevents complete disappearance. It gives the mind something firm to work with. In a way, Riversleigh's fossils are not just remains of animals, they are remains of interactions between animals and place. A bat fossil points to caves, night air, insects and roosting spaces. A crocodile points to water and prey. A turtle points to aquatic habitat. A browser points to vegetation. A predator points to prey communities. A tiny mammal points to ground cover or trees, depending on its anatomy. The limestone itself points to mineral-rich water. Taken together, they show a system. This is why the making of fossils is not a side issue in the Riversleigh story. It is central. The way the fossils formed is the reason we can see the lost world at all. And as the old forest moved through its days, the future record was being made in patches. One place preserved a cave community. Another preserved animals around a pool. Another held a different moment, a different mix, a different slice of time. Some deposits would later produce spectacular skulls. Others would produce small fragments that answered narrow but important questions. Some would become famous. Some would remain mostly known to specialists. The land was not making one grand monument. It was making many small locked rooms, each containing a different part of the story. The calmest way to think about it is this. Riversleigh became extraordinary because life, death, water, and limestone met there again and again. The animals made the world lively. The pools made it concentrated. The caves made it sheltered. The minerals made it durable. Time made it ancient. Scientists made it readable. None of those parts alone would have been enough. A forest without preservation becomes memory only. A limestone landscape without life tells a different geological story. A fossil without context is a clue with its address missing. But together, they created a record rich enough to let us walk carefully through a vanished Australia. So, When we imagine Riversley now, we should not picture only the creatures moving through shade. We should also picture what was happening beneath and around them. Mineral-rich water flowing through limestone, caves widening in the dark, pools collecting sediment, bones settling where scavengers could not reach them, calcium carbonate forming layer by layer, openings closing, deposits hardening. The ancient forest was alive above ground, but below and beside it, another process was already beginning, slow, chemical, and patient. It was taking the ordinary remains of ordinary deaths and turning them into something that could survive long enough to meet a species capable of asking what had happened there. And once that record was sealed in stone, Australia itself kept changing around it, carrying those fossils forward into a drier world where the old rainforest was gone, but not entirely erased. By the time Riversley's pools and caves had begun locking pieces of the old forest into limestone, Australia itself was still on a much larger journey. Not the sort of journey that requires luggage, snacks, and someone asking whether we are nearly there yet, but a continental journey, slow enough that no animal felt it happening, and powerful enough to change the fate of nearly every animal alive on the land. Australia had once been part of the great southern supercontinent Gondwana, connected in deep time to land masses that would become Antarctica, South America, Africa, India and Madagascar. But continents do not stay politely seated forever. They split, drift, collide, tilt, stretch, and wander across latitudes with a kind of geological stubbornness. Australia separated from Antarctica and moved northward, carrying its forests, animals, rivers, climates, and evolutionary experiments along with it, like a vast raft with no captain and an impressive disregard for schedules. That northward movement mattered. A continent is not just a slab of rock with scenery on top. Its position affects rainfall, temperature, ocean currents, winds, vegetation, and the opportunities available to life. When Australia was farther south and closer to Antarctica, much of it was wetter and more forested. As it drifted north and global climates shifted, the continent gradually moved into different climatic zones. Over millions of years, many Australian landscapes became drier. Rainforests that had once spread more widely began to contract into refuges. Open woodlands, grasslands, shrublands, and arid habitats expanded in many places. Riversley is important because it preserves evidence from this time of transition, with fossil assemblages showing changes in habitat, from humid lowland rainforest toward drier eucalypt forests and woodlands, from the Oligocene to the Miocene. UNESCO specifically notes that Riversleigh helps show the rainforest origins of many mammal groups that today occupy much drier parts of Australia. That is a rather large idea tucked into a fossil site. The animals we now associate with dry country, open woodland, scrub or grassland may have deeper family histories tied to wetter forests. Evolution does not always begin where we expect it to. It is a little like discovering that someone who now lives in the desert and wears excellent sun protection actually grew up in a damp village where everything smelled faintly of moss. Modern Australian mammals did not simply appear in the environments where we see them today. Their ancestors moved through older worlds. Some lineages began in forests, then later adapted to more open or drier places. Others remained tied to wet habitats and declined as those habitats shrank. Still, others vanished completely, leaving no living descendants to explain themselves. Riversleigh gives us a long view of that transformation. It is not just a window into one rainforest. It's a record of changing faunas across millions of years, roughly from the Oligocene into the Miocene, often described in the range of about 30 to 10 million years ago. Queensland's Environment Department describes Riversleigh as once being a lush rainforest scattered with lime-rich freshwater pools, with outstanding fossils from the Oligocene to Miocene preserving the unique story of Australia's wildlife evolution. But the key point is that the rainforest did not remain the same. It shifted. The wider climate shifted. The animals shifted with it, or they did not. And in that difference, between adaptation and disappearance, we begin to see evolution not as a tidy ladder, but as a series of experiments under changing conditions. Isolation made those experiments especially unusual. Australia is often called the world's most isolated continent, and the Australian government describes the Australian fossil mammal sites, including Riversleigh, as illustrating key stages in the evolution of the unique fauna of Australia, the world's most isolated continent. Isolation does not mean Australia was sealed in a glass jar forever. Bats, birds, and some other animals could arrive by flight or over water. Sea levels changed, connections and distances shifted over geological time. But for many terrestrial mammals, especially marsupials, Australia's long separation created space for distinctive radiations. In other parts of the world, many ecological roles were filled by placental mammals: cats, dogs, deer, antelope, monkeys, bears, and so on. In Australia, marsupials diversified into forms that browsed, grazed, climbed, glided, burrowed, hunted, and scavenged. Evolution had the same basic problems to solve: finding food, avoiding death, raising young, moving through habitats, but it solved them with different starting materials. This is why Riversley can feel so wonderfully disorienting. We recognise the ecological roles, but not always the animals wearing them. A predator appears, but it is a marsupial lion rather than a cat. A dog-like hunter appears, but it is a thylacine relative rather than a wolf. A large plant-eating animal browses, but it belongs to an extinct diprotodontoid lineage related in broad terms to the great marsupial herbivore story of Australia. A crocodile may behave in ways that do not match the modern crocodile stereotype. A kangaroo relative may have fangs. A small odd mammal may have teeth so unusual that scientists place it in a category of its own. The continent was not copying the rest of the world. It was improvising from its own history. That does not mean evolution was random in a casual sense. Natural selection works through survival and reproduction under real conditions. Teeth fit diets, limbs fit movement, senses fit habitats. Body size responds to food, predators, climate, and competition. But the starting line matters. If one continent has placental carnivores and another has marsupial carnivores, the animals may converge on similar roles without becoming the same thing. A thylacine can resemble a dog in overall outline because both were mammalian predators, built for moving on land and taking animal prey, but that does not make it a dog. It is a marsupial lineage finding a similar solution to a similar ecological problem. Convergence is evolution's way of reminding us that life can arrive at comparable shapes through very different roads, which is both elegant and slightly confusing if you're trying to explain it at bedtime. Riversleigh's fossil record shows these odd experiments in progress. The Australian Museum describes Riversleigh as having fossils from more than 250 fossil-rich sites, with hundreds of new species described from thousands of well-preserved specimens, including ancestors and representatives of kangaroos, bandicoots, wombats, thylacines, koalas, possums, bats, rodents, platypuses, and extinct groups such as diprotodontids and thylacolenids. That diversity matters because it lets scientists see not only isolated examples, but patterns. Some groups were diversifying, some were changing in body size, some were responding to shifts in habitat, some were disappearing as conditions altered. A single fossil can tell us that an animal existed. A sequence of fossils can tell us how a lineage responded when the world around it changed. Consider the kangaroo story. Today, many people think of kangaroos as animals of open country, hopping across grasslands, woodlands, and dry inland places. But the deeper history of kangaroos and their relatives is more complicated. Riversleigh preserves ancient macropodiforms, including extinct groups such as balbarids, and researchers found significant faunal turnover among Riversleigh kangaroos around the time of the Miocene climatic optimum, with body mass increasing through time for many taxa. That phrase, faunal turnover, sounds very tidy, like rearranging a shelf. In reality, it means some forms became less common or disappeared, others appeared or expanded, and the structure of the animal community changed. Over long timescales, the cast of the ecosystem was being rewritten. The Miocene climatic optimum itself was a warm interval, roughly in the middle Miocene, when global temperatures were higher than before and after. Riversley is unusual because it records rich animal communities during and after this major climatic event. A Queensland climate snapshot describes Riversley as the only place in the world with a fossil record of rich fauna during and following the mid-Miocene climatic optimum. That makes the site important not just for naming extinct animals, but for asking how animal communities respond to climate change. What happens when forests shift? What happens when rainfall changes? Which lineages persist? Which ones decline? Which animals manage to adjust their diets, ranges or body sizes, and which are too tied to old conditions to survive the new ones? Of course, climate change in deep time did not work like a switch. The forest did not wake up one morning, find a note saying, "You are now woodland," and start packing leaves into boxes. Change happened unevenly, over long periods, across different regions. Some places dried earlier or more severely. Some wet refuges remained. Some habitats became mosaics, with forest patches, open areas, waterways, and woodland existing near one another. Riversley's own record suggests environmental variation through time. Studies of its Oligocene sites have suggested changes from more open forest in the late Oligocene to rainforest in the early and middle Miocene, and then toward open forest again in the early late Miocene. That is much more interesting than a simple story of rainforest becoming desert. The past was layered, patchy, and regionally complex because nature has never been especially interested in making narration easy. For animals, patchiness creates both challenges and opportunities. A specialist adapted to dense rainforest may do very well, while that habitat is widespread. If the forest contracts, that same specialization can become a problem. An animal that can tolerate edges, drier conditions, or more open vegetation may expand. A predator may follow prey into new habitats, or fail if its hunting style depends too much on cover. A browser may decline if soft rainforest plants become less available. A grazer may benefit later as more open vegetation spreads. Body size can change as food sources, temperatures, and predator pressures change. Teeth can change as diets shift. Limb proportions can change as movement demands change. Evolution works through individuals living or dying, reproducing or not reproducing, but over millions of years those small outcomes accumulate into visible transformations. This is where Riversleigh becomes a record of both stability and disruption. Some lineages continued through changing conditions, though not always unchanged. Others were replaced. Some ancient forms belong to groups that still have living relatives, while others are branches that ended. The old rainforest held animals that would seem unfamiliar today, yet many were connected to modern groups. Koalas, for instance, are now associated with eucalyptus leaves, a diet so specialized that it feels like a personal decision made with surprising confidence. But fossil koala relatives from Riversleigh show that the koala family has roots going back into ancient forested environments. The Australian Museum notes that early fossil koalas from Riversleigh, such as Nimio koala, Madder koala and Pericoala, were part of the early history of the koala lineage. That does not mean modern koalas are simply ancient rainforest animals wearing new fur. It means their lineage passed through older habitats before the modern eucalyptus specialist became the familiar form. The same broad point applies to many Australian groups. A living animal is the end result of many former environments, not only its present one. Its anatomy may carry traces of old diets, old habitats, old relationships, and old constraints. Sometimes those traces are obvious. Sometimes they are hidden in teeth, genes, bones, or behaviour. Fossils give us the physical evidence needed to connect the present with earlier stages. Without Riversleigh, many of those connections would be far dimmer. The continent would still have its modern wildlife, but less of the backstory. Isolation also encouraged ecological substitutions that can seem almost playful from a distance. Marsupial moles, marsupial carnivores, gliding possums, kangaroos, Wombat relatives, koalas, bandicoots and other groups filled roles that elsewhere might be associated with very different mammals. It is important not to overstate this as if every Australian animal is just a marsupial version of a Northern Hemisphere animal. That would be too simple, and also a little rude to the animals, who did not spend millions of years evolving only to be described as someone else with a pouch. But there are real examples of convergent roles. Australia's long isolation let marsupials diversify into ecological spaces in ways rarely seen elsewhere. Riversley shows earlier stages of that diversity, before the modern fauna had settled into its present shape. The odd experiments were not limited to mammals. Ancient crocodilians in Australia included forms very different from modern crocodiles. Some mecosuchenes were more terrestrial, and Riversleigh has produced material from crocodiles that suggest varied habits, including the possibility of climbing in some forms. Giant dromornithid birds, such as Dromornis murray from Riversleigh, add yet another experiment. Large, flightless, plant-eating birds in the ancient Australian landscape. UNSW describes Dromornis murray from Riversleigh as about 26 million years old and around 250 kilograms, making it a major herbivore in its time. When these animals are placed alongside marsupial predators and browsing mammals, the ecosystem becomes a reminder that evolution builds communities, not just species. Each odd body makes sense only inside the world that shaped it. A changing continent also means changing opportunities for movement. As rainforests contracted, animals that depended on continuous forest may have become isolated in pockets. Isolation within isolation can drive further evolution. Populations separated by unsuitable habitat may diverge. Small populations may be more vulnerable to extinction. At the same time, expanding open habitats can connect regions for animals adapted to them. A creature suited to woodland or dry scrub may find new corridors opening, while a rainforest specialist finds its world broken into islands. Over time, these shifts rearrange the map of life. Some animals follow the retreating wet zones. Some adapt to the new open conditions. Some remain in refuges. Some disappear. This makes Riversleigh especially valuable because it sits at the intersection of climate, geography and biology. The fossils are not simply old, they come from a period when major changes were underway. They help show that Australia's modern dryness was not the eternal condition of the continent. It developed through long processes, and because the animals were changing alongside those processes, Riversleigh becomes a natural experiment in deep time. It shows what happened when a distinctive fauna met environmental change over millions of years. That does not give us a simple formula for today, but it does give perspective. Life can adapt, yes. Life can also fail to adapt. Extinction is not a dramatic exception. It is one of the normal outcomes when conditions move faster, farther, or differently than a lineage can follow. There is a temptation, when talking about evolution, to make it sound clever, as if animals deliberately invented new bodies to solve problems. A kangaroo lineage notices more open land and says, perhaps hopping would be efficient. A predator glances at prey and orders slicing teeth. A browser sees changing vegetation and revises its dental plan before breakfast. But evolution is not planned in that way. Individuals vary. Some variations help survival or reproduction in a given environment. Those traits become more common. Other traits become less common. Over long periods, the result can look purposeful, but it is built from countless small tests imposed by daily life. The old Riversleigh animals were not trying to become modern. They were only trying to live where they were. That is why the phrase, evolution's odd experiments, should be taken gently. Evolution does not conduct experiments with a clipboard. The experiment is simply life meeting conditions. At Riversleigh, conditions included wet forests, freshwater pools, caves, shifting climates, long isolation, and later more open habitats. The results included marsupial lions, early kangaroo relatives, strange browsing herbivores, thylacines, bats, koala relatives, giant birds, crocodiles with surprising habits, and mammals so peculiar they resist easy comparison. Some results lasted, some ended, some left descendants. Some left only fossils and the awkward task of being named by humans much later. The more one thinks about it, the more Australia's isolation seems less like a wall and more like a workshop. Inside that workshop, lineages had room to diversify in directions that might have been impossible or less likely elsewhere. Marsupial predators could become important land hunters. Herbivorous marsupials could expand into many browsing and grazing roles. Flying mammals such as bats could arrive and diversify. Birds and reptiles remained important players. But the workshop was never stable. The roof leaked, then dried. The temperature changed. The shelves moved. The lights brightened and dimmed. Climate kept altering the conditions under which evolution worked. Isolation allowed distinctive forms to arise. Climate change tested them. There is something oddly calming about seeing modern Australia as one moment in a longer sequence. The country we know today, with its deserts, savannas, eucalypt woodlands, rainforests tucked into wetter regions and unique animals, is not the final answer to anything. It is the current arrangement. Riversley shows older arrangements. It shows that rainforests once held lineages now linked with very different habitats. It shows that predators and herbivores came and went. It shows that environments shifted enough to reshape entire communities. The land changed, and life changed with it, leaving behind a record in limestone for an animal with notebooks and curiosity to find later. If we could stand at Riversleigh at different points across those millions of years, we would not see one smooth transformation. We would see different versions of the landscape. At one time, more closed forest and pools under shade. At another, perhaps more open forest with different light reaching the ground. Later still, drier vegetation spreading in wider patches. The animals would differ too. Some familiar lineages would appear in earlier forms. Some strange groups would vanish from the scene. Body sizes would shift. Teeth would tell new diet stories. Predators would change with the prey available. The continent would keep moving north. The climate would keep changing. And the animals would keep answering as best they could, though not all answers would work forever. And beneath these changes, the fossil record would continue to form in pieces. A pool here, a cave there, a deposit from one interval, then another from a later one. Each deposit preserving not only animals, but a particular state of the continent's long experiment. This is why scientists can read Riversleigh as more than a catalogue of creatures. It is a record of response. It shows life under changing rainfall, changing vegetation, changing temperature, and changing ecological pressure. It shows what happened when old rainforest worlds began giving way to newer landscapes. It shows that the animals of Australia were shaped not only by isolation, but by repeated environmental challenge. So the lost world of Riversleigh was never separate from the changing earth around it. The forest, the pools, the caves, and the animals were all part of a moving continent under a shifting sky. Australia's isolation gave its creatures room to become wonderfully distinctive. Climate change gave them tests they could not ignore. Evolution produced forms that now seem strange because they belong to combinations of habitat and history that no longer exist. And as the rainforest thinned in places, as drier conditions spread, as old lineages adjusted or disappeared, the rocks kept receiving evidence. Teeth, skulls, jaws, shells and bones settled into limestone. Later, scientists would lift them back into daylight and begin asking what kind of world could have made such animals. The answer was not one thing, not just forest, not just dryness, not just isolation, not just change, but all of them together, working over millions of years, leaving behind a continent full of survivors, ghosts and family histories written in bone. Reading a fossil is not quite like reading a normal story. There are no neat paragraphs, no helpful punctuation, no character introductions, and absolutely no one has had the courtesy to write. Here enters the small rainforest koala, looking nervous. Instead there is a jaw, a tooth, a skull with one side missing, a limb bone still held in limestone, a few fragments that seem almost too small to matter until someone who has spent years looking at such things leans closer and realises they matter very much indeed. Riversley's fossils are like pages torn from an enormous book, scattered across time, many of them damaged, some of them still sealed shut, and others written in a language made of enamel, bone, mineral and absence. The work of science is to learn how to read them without pretending they say more than they do, which is a delicate balance, a little like listening to someone whisper from 20 million years away, while a geologist politely asks everyone to stop stepping on the evidence. What Riversleigh reveals, when read patiently, is not only that strange animals once lived in northern Australia. That would already be enough to make the place fascinating, especially when some of those animals include marsupial lions, ancient thylacines, giant flightless birds, rainforest koalas and crocodiles that do not behave as modern crocodiles are expected to behave. But Riversleigh reveals something deeper than a cast list. It shows memory, not human memory, not the kind that keeps birthday dates, old songs, or the exact embarrassing thing we said 12 years ago while trying to sound clever. It shows biological memory, the long record of life changing through time. It preserves traces of bodies, and those bodies preserve traces of habits, habitats, ancestry, diet, movement, and extinction. It is one of the reasons Riversley is recognised as part of the Australian Fossil Mammal Site's World Heritage Property, with UNESCO describing Riversley as preserving exceptional and often unique mammal assemblages from the Oligocene to Miocene, spanning roughly 10 to 30 million years ago. That span of time is difficult to feel properly. 10 million years is already far outside ordinary imagination. 30 million years is the sort of number that behaves badly in the mind, like trying to picture every raindrop in a storm and then being told the storm lasted all afternoon. So it helps to bring the scale down for a moment. Think of one tooth, just one. A small, hard piece of an animal's body, built to meet food every day. Teeth are among the most useful fossils because they are durable, distinctive, and closely tied to diet. A sharp slicing tooth says one thing, a broad grinding tooth says another. A tooth built for crushing hard material has a different story from one built for shearing flesh or processing leaves. In life, a tooth is an ordinary tool. In death, if preserved, it becomes a tiny record of how an animal made a living. Riversley has thousands of such clues, and together they allow scientists to reconstruct not just who was there, but what they were doing. A jaw can tell a bedtime story if you know how to listen. Not the kind with a soft blanket and a sleepy ending, perhaps, but a story all the same. The shape of the jaw can reveal how muscles pulled, how powerful the bite may have been, how teeth came together, and what kinds of food the animal could process. A skull can tell us about senses. The position of eye sockets can suggest how the animal used sight. The structure of the ear region can help with relationships and in some cases hearing. Openings in the skull show where nerves and blood vessels passed. Limb bones can hint at whether an animal climbed, walked, leapt, dug, or swam. A fossil is rarely a full confession, but it is often enough to begin a careful reconstruction. It says, quietly, this animal did not just exist, it had a way of being. Take Nimiokoala gristanisi, a small rainforest koala from Riversleigh. The living koala is so closely associated with eucalyptus leaves that it can feel as if koalas and eucalyptus made some ancient private agreement and then refused to discuss alternatives. But Nimiokoala belonged to an earlier part of the koala family story. The Australian Museum describes it as a small early Miocene koala from northern Australia, represented by a well-preserved skull, with a longer snout than the living koala, and a body only about a third of its size. It likely fed on forest leaves, though whether it specialised on eucalypts as living koalas do remains uncertain. That single animal changes the way we think about koalas. The modern koala is not simply a sleepy creature that appeared fully formed in a eucalyptus tree one afternoon, looking mildly annoyed. It is the surviving member of a deeper and more diverse family history. Riversley helps bring that history into view. And this is where fossils begin to feel like memory. A living animal carries its ancestry inside its body. Its bones, teeth, organs, behaviour and genes all come from earlier forms modified across generations. But once a lineage narrows to a single living species, much of its former variety disappears from sight. Fossils restore some of that missing breadth. They show us that a group now reduced to one living branch may once have had many branches. Koalas were once more diverse than they are today. Thylacines were once more diverse than the recently extinct Tasmanian tiger alone. Marsupial carnivores included forms that filled roles. No living Australian mammal fills in quite the same way. Riversley does not just add extinct creatures to a list. It shows that the present is thin compared with the past. What survives now is only a small part of what life has tried. The same is true for the thylacine story. The last thylacine, filmed in the 20th century, has become a symbol of recent extinction, and understandably so. There is something haunting about seeing an animal move on film while knowing that the living lineage ended soon after. But Riversley pushes the story far behind that final image. It reveals older thylacines, multiple species, earlier forms, and a deeper history of marsupial predators in Australia. The Australian Museum notes that Riversley fossils altered understanding of Australia's mid-Cainozoic vertebrate diversity and include representatives and ancestors of thylacines, among many other groups. In that sense, Riversley turns the thylacine from a single lost animal into the final known survivor of a long evolutionary family. The ending is still sad, but it becomes part of a larger story, and larger stories often change the weight of grief. They do not remove it, but they give it roots. Riversley's memory is not only about individual lineages, it is about communities. A fossil site with one animal can be important, but a site with many animals from many deposits across millions of years can begin to reveal how life was arranged. Which animals lived together? Which environment supported them? Which groups appeared, expanded, declined, or vanished? Which habitats were wet, forested, open, or changing? Fossil communities are not perfect photographs, because the record is filtered by preservation, transport, erosion, and discovery. But Riversley's record is rich enough to let scientists ask these broader questions. The Australian Museum describes Riversleigh as having more than 250 fossil-rich sites, and hundreds of new species described from thousands of well-preserved specimens, with many more still undescribed or undiscovered. That is not a single memory. It is a long archive. An archive like this lets paleontologists compare. Comparison is one of the great quiet tools of science. A fossil by itself may be strange. A fossil compared with another fossil becomes informative. A fossil compared with a living animal becomes a clue to function. A fossil compared across layers becomes a marker of change through time. One deposit might show a fauna adapted to wetter forest. Another might show signs of more open habitats. One animal group might appear in older deposits and be absent from younger ones. Another might diversify as conditions shift. Riversley therefore helps reveal not only what lived, but how Australia's animal communities changed as environments changed. UNESCO notes that Riversley's assemblages document changes in habitat from humid lowland rainforest to dry eucalypt forests and woodlands, and show the rainforest origins of groups that later occupied very different environments. That is one of the site's most important lessons. The animals we see today are not fixed symbols of fixed landscapes. Kangaroos were not always creatures of the open country, in the way we usually picture them. Koalas were not always only the modern eucalyptus specialists we know. Thylacines were not always represented by one late survivor. Australian wildlife has a long memory, and Riversley lets that memory become visible. It shows that modern ecosystems are not final arrangements but temporary outcomes. The present is not the goal of evolution. It is just the page we happen to be standing on. There is also a lesson in what is missing. Fossils show us what survived preservation, not everything that lived. Soft-bodied creatures are underrepresented. Many plants are known indirectly or from other kinds of evidence rather than from the same spectacular preservation as bones. Behaviours are often inferred, not seen. Sounds are gone. Colours are mostly gone. The exact texture of fur, the daily movements of a mother and young, the call of a bird in the canopy, the smell of a wet limestone pool after rain, all of that has vanished. Riversleigh's memory is powerful, but it is not complete. It is more like an old recording with sections missing than a perfect replay. And yet, even an incomplete memory can be deeply revealing. Sometimes one tooth can preserve what a whole forest forgot to say plainly. The fossils also reveal how much of life depends on relationships. A predator's tooth means prey. A browser's molar means plants. A bat's wing bones mean night air, insects and roosts. A crocodile means water, shorelines and animals that came too close. A frog means moisture. A turtle means aquatic habitat. A small rainforest koala means trees and leaves. Every fossil points beyond itself. This is why reading bones is not only about naming animals. It is about reconstructing the web of conditions that made those animals possible. A creature is not an isolated object. It is a solution to a world. And Riversleigh's world was changing. That matters because biological memory is not just memory of forms, but memory of responses. When climate changed, habitats shifted. As forests contracted or opened, animals faced new pressures. Some lineages adjusted, some moved, some declined, some disappeared. The fossil record lets us see these responses across deep time, not as guesses, but as patterns in preserved faunas. Queensland's Environment Department describes Riversleigh and Narra Court as superb examples of key stages in the evolution of Australia's unique wildlife, with Riversleigh preserving fossils from a once lush rainforest scattered with lime-rich freshwater pools. That pairing of lush ancient habitat and modern dry country is important. It reminds us that landscapes can change so completely that the present surface becomes almost a mask over an older ecological face. If we read Riversleigh carefully, we also read extinction differently. Extinction is often imagined as a sudden disappearance, a final moment, the last individual, the last call, the last footprint. Sometimes it may happen quickly. Often it is slower. A lineage becomes less diverse. Its habitat shrinks. Its range contracts. Populations become isolated. The animal persists in pockets, then fewer pockets, then perhaps only one. Eventually there is no pocket left. Fossils help reveal the earlier richness that extinction removes. Without them, we might think the living world was always as narrow as it is now. Riversleigh shows that many groups once had more forms, more experiments, more ecological roles. Extinction is not only the loss of species, it is the loss of possibilities. This is especially clear when we think about animals like marsupial lions. Today, Australia has no living thylacolionid. The group is gone. Without fossils, we would not know that marsupial predators once evolved slicing teeth and powerful forms that filled major carnivorous roles. The fossil record preserves the fact that this happened. It keeps a memory of a type of animal the living world no longer contains. The same is true for dromornithid birds, for extinct crocodilian forms, for odd mammals like Yalcaparodon, and for ancient members of lineages now reduced or transformed. Riversleigh is a reminder that life's library has burned many books, but a few pages survived in stone. There is comfort in that, though it is a strange comfort. Fossils do not undo loss. They do not bring back the animals, restore the rainforest, or reverse time, but they prevent total erasure. They allow vanished creatures to become part of knowledge. They let us say this animal lived. It had teeth like this, a skull like this, a body that moved through this kind of world. It belonged here, among these pools, forests, caves, and other animals. It was not imaginary, not merely possible, but real. For creatures gone millions of years, that is no small thing. The work of reading those bones continues. Many Riversleigh fossils have been described, but many more remain under study or undescribed. That is not surprising. A site this rich can outpace the people studying it. Fossil preparation takes time. Comparison takes time. Naming a species responsibly takes time. And science itself changes. New methods allow old specimens to be examined in new ways. CT scanning can reveal structures inside fossils without destroying them. Improved dating methods can refine timelines. New discoveries can shift relationships. A fossil collected decades ago may suddenly become important when a related specimen is found. The archive is old, but the reading is ongoing. This ongoing work is one of the reasons Riversleigh still feels alive as a scientific place. Not alive in the biological sense, of course, though one should never underestimate the enthusiasm of field insects. It is alive because it continues to produce questions. Each answered question opens another. If this animal lived here, what did it eat? If this lineage appears at this time, where was it before? If this group disappears, what changed? If rainforest animals gave rise to lineages now associated with drier habitats, what steps connect them? If several predators lived together, how did they divide food and space? The fossils do not deliver a single finished story. They keep offering evidence that must be fitted carefully into a larger pattern, and that pattern reaches beyond Riversleigh. The site is paired in the World Heritage listing with Naracoorte, which preserves a much younger fossil record from the Pleistocene. Together, Riversleigh and Naracoorte help illustrate different stages in the evolution of Australia's mammal fauna. Riversleigh with older Oligocene and Miocene assemblages, and Naracoorte with more recent records that help show responses to late Quaternary conditions. UNESCO presents the combined sites as outstanding examples representing major stages of Earth's history and the record of life. This pairing gives Australia a fossil memory with depth and range. One site shows ancient rainforest origins and mid-Cenozoic diversity. The other helps illuminate a later world closer to the animals and extinctions of the recent past. Together they remind us that the history of life is not one scene, but a sequence of changing scenes. Riversleigh also reveals how science depends on patience shared across generations. One person may find a fossil, another may prepare it, another may describe it, another may revise the interpretation years later. Students become researchers. Old field notes become valuable. Museum collections become active scientific resources. A fossil in a drawer is not finished just because it has been collected. It may wait quietly until someone asks a new question. This is another kind of long memory. The memory held not only by stone, but by institutions, field teams, collections, and the accumulated work of people who cared enough to keep the evidence safe. There is a gentle parallel here with bedtime stories, although the subject matter has rather more jaw fragments than the average nursery shelf. A bedtime story is often repeated. Each time the listener may notice something different. A detail that seems small becomes meaningful. A character's action makes more sense. The ending feels different because the listener has changed. Riversleigh works in a similar way. Scientists return to the same fossils, the same deposits, the same questions, and each return can reveal something new. The story was always there in the stone, but the ability to read it improves. If we imagine one fossil skull from Riversleigh resting on a table, cleaned from its limestone, labelled and lit softly from above, it seems quiet. But inside that quiet object are many timescales. There is the life of the animal itself, perhaps years. There is the time of decay and burial, perhaps days, seasons, or longer. There is the time of mineralization, stretching far beyond any living concern. There is the geological time that kept it sealed. There is the field season when it was found. There is the preparation time in the laboratory. There is the scientific time of study and publication. There is the museum time of preservation for future researchers. One skull holds all of that. It is a small object carrying a very long chain of events. What Riversleigh reveals, then, is that life's memory is not stored in one place. It is stored in bodies while they live, in genes passed through generations, in ecosystems shaped by interactions, in bones after death, in sediments, in caves, in limestone, in museum collections, in scientific names, and in the minds of people who learn the story. The memory is fragile at every stage. A bone can dissolve, a site can erode, a specimen can be damaged, a habitat can vanish, a species can go extinct, and yet some memory survives. Enough survives at Riversleigh to let us glimpse a lost Australia with unusual clarity. This long memory has meaning for the present too. When we look at living animals, especially endangered ones, we're not only seeing individuals, we are seeing the latest carriers of histories that may stretch back millions of years. A modern koala is not just a modern koala, it is the surviving representative of a once more diverse family. A bat is part of a long history of night flight and ecological adaptation. A crocodile is connected to ancient reptile stories that have changed many times. Living species are not replaceable units. They are the current expressions of old lineages. Fossils help make that visible. They deepen the value of what remains. So, as we keep moving through Riversleigh's story, it helps to hold this idea gently. The rocks are not merely showing us death. They are showing us continuity, change, and the astonishing persistence of information. A rainforest vanished but not completely. Its animals died, but not all trace of them was lost. Their bones entered pools and caves. Limestone held them. Scientists read them. Now the lost world can be spoken of again, not as myth, not as guesswork, but as a careful reconstruction built from evidence. And once we understand that a place can hold memory for tens of millions of years, the next question becomes quieter, but more urgent. What do we do with that knowledge now, in a world where living ecosystems are changing again, and where the difference between remembering and losing can depend on how carefully we pay attention? Riversleigh matters today because it refuses to stay neatly in the past. At first, it seems like a place for ancient bones, scientific names, and animals that disappeared so long ago that even their ghosts would need directions. It is easy to imagine it as a world safely behind glass, something for museums, researchers, and people who enjoy words with more syllables than strictly necessary before bedtime. But the longer we stay with Riversleigh, the more it becomes clear that this lost world is not just a curiosity. It is a record of change. It is a warning. It is a reference point. It is one of those rare places where the Earth has kept enough evidence for us to compare then with now, and to ask what happens when climate, habitat, and living communities begin to shift. UNESCO describes the Riversleigh and Narracourt fossil sites as a globally significant record of key stages in the evolution of Australia's mammals, including their responses to climate change and human impacts. That last part is what brings Riversleigh into the present. It is not only about what Australia's animals once were, but about how animals respond when the world around them changes. And that question is not ancient at all. It is very much awake, sitting at the edge of the bed, holding a notebook, and asking whether we have been paying attention. The old Riversleigh forest changed slowly over millions of years. Rainfall shifted, temperatures changed, habitats opened and closed, lineages adapted, moved, diversified, declined, or disappeared. Today habitats are changing again, though for different reasons and often at speeds that make the past feel less like a distant story, and more like a training manual we only partly understand. A fossil site cannot predict the future in a neat way, because nature has never been fond of giving simple exam answers. But it can show patterns. It can show vulnerability. It can show resilience. It can show that when ecosystems change, animals do not all respond in the same way. This is one reason the word lost needs some care. Riversleigh's ancient world is lost in the sense that we cannot bring it back. The rainforest communities preserved there are gone. The marsupial lions, early thylacines, giant birds, strange browsers, old crocodilians and many smaller animals no longer move through those pools and caves. but the world is not lost in the sense of being useless, finished, or sealed away from meaning. It still speaks through evidence. It still helps scientists understand the roots of modern Australian wildlife. The Australian government describes Riversleigh, together with Narracoorte, as among the world's 10 greatest fossil sites and notes that these places help us understand the history of mammal lineages in modern Australia. That means a fossil jaw from a long-vanished animal may still have something to say about living animals that breathe under the same sky today. The present-day value begins with knowledge. That may sound obvious, but it is worth saying gently because knowledge is sometimes treated like a luxury, something nice to have after the practical things are done. Riversley shows why it is more than that. Without the fossil record, we would see modern Australian animals as if they had appeared from nowhere. Kangaroos would simply be kangaroos. Koalas would simply be koalas. Bats, wombats, bandicoots, possums, thylacine history, carnivorous marsupials, giant birds, all of them would have much thinner stories. Riversley gives depth to the living world. It reveals that many groups were once more diverse, that some modern animals are the narrow surviving ends of much broader family trees, and that ecosystems can be completely rearranged by time. The Queensland government describes Riversleigh as one of the most significant paleontological sites in the world and notes that its fossil bat record alone includes 35 species, making it one of the richest known records of fossil bats. That bat record is a good example of why small fossils matter. Bats are not usually the animals that dominate popular prehistoric imagination. They do not stand in museum halls like towering skeletons with a spotlight on their ribs. Their bones are delicate and their bodies are small. But bats are deeply important to ecosystems. They eat insects, pollinate plants in some regions, disperse seeds, and fill the night with movement that most of us barely notice unless one flutters past a porch light and causes someone to make a noise they later insist was not a scream. Riversleigh's fossil bats reveal ancient diversity and show that the night skies of old Australia were busy with forms that help us understand how these animals evolved. When a fossil site preserves delicate creatures as well as larger ones, it gives a much fuller picture of the world. It tells us not just about the impressive animals, but about the texture of daily life. Riversleigh also matters because it gives scientists a rare long-term view of climate change in Australia's past. This is not the same as saying the past and present are identical. They are not. Ancient climatic shifts unfolded under different conditions, without modern industry, modern land clearing, invasive species, or the speed and scale of current human influence. But deep time records still matter because they show how animal communities responded when temperature, rainfall, vegetation and habitat structure changed. Queensland's climate material describes Riversleigh as offering a unique opportunity to learn from past climate change impacts on Australia's mammals, including a fossil record from during and after the mid-Miocene climatic optimum, a major warming event. That comparison is not a bedtime comfort in the simple sense. It does not say, do not worry. Life has survived change before, so everything will be fine. Life has survived many changes, yes, but not always as the same life. The Earth can continue while species vanish. Ecosystems can recover while particular lineages disappear forever. Forest can become woodland, woodland can become scrub, and an animal beautifully adapted to one world may find itself poorly suited to the next. Riversleigh teaches that survival is selective. Some branches continue, others end. The fossil record is full of both persistence and loss. That is precisely why it matters now. It reminds us that change is not automatically gentle, just because it is natural in the broadest sense. The outcome depends on speed, scale, habitat, movement, reproduction, competition, and chance. There is another present-day lesson in the relationship between habitat and identity. We often define animals by where they live now. Koalas belong in eucalyptus forests. Kangaroos belong in open country. Crocodiles belong in rivers and wetlands. But Riversleigh complicates those labels. It shows that the ancestors and relatives of modern groups lived in different settings, including older rainforest environments. This helps scientists understand that the modern habitat of a species may not tell the whole story of its lineage. It also reminds us that when habitats change, animals may not simply pick up and move as if choosing a new apartment with better parking. Their bodies, diets, reproductive habits, and ecological relationships place limits on what is possible. A specialist may be very successful in stable conditions and very vulnerable when those conditions disappear. This is true in the fossil record, and it is true now. For conservation, long memory is useful. Modern conservation often has to make decisions under pressure, with limited time, limited money, and far too many species needing help. Fossils cannot make those decisions for us, but they can provide context. They show how long lineages have existed, how much diversity has already been lost, and how habitats have shifted in the past. The 2023 to 2030 Riversley Research Priorities document notes that research can help manage the property's values, and even refers to landscape-level studies that use Riversley's fossil record to understand the conservation of modern Australian animals, including examples such as the mountain pygmy possum. That connection between ancient bones and living conservation may seem surprising at first, but it makes sense. To protect a species, it helps to know where it came from, how its relatives responded to change, and what kinds of ecological pressures have shaped it. A place like Riversleigh also matters because it changes public imagination. That sounds softer than scientific research, but it is powerful. People tend to protect what they can understand, and they tend to understand what has been made vivid to them. A dry limestone landscape may not immediately look like a rainforest archive. A fossil tooth may not immediately look like a message from deep time. But when the story is told carefully, the place becomes alive in the mind. The visitor, listener, or reader begins to see that the ground is not empty, it is layered. It contains vanished climates, vanished animals, vanished relationships. That kind of understanding can make people less careless. Not perfect, of course. Humans remain remarkably capable of stepping over signs, ignoring barriers, and treating ancient places as if they are there mainly to improve a holiday photograph. But wonder can become responsibility if it is given enough time to settle. Responsibility matters because Riversley is not indestructible. Fossil sites are vulnerable to erosion, flooding, unauthorized collecting, careless visitation, and the slow wear of exposure. The Queensland State of the Environment reporting describes Riversley as the richest known fossil mammal deposit in Australia, with an overall conservation outlook that remains good, though it also notes that threats exist and require management. A fossil can survive millions of years in limestone and still be damaged by one careless human action. This seems almost unfair, but it is true. Deep time does not make evidence invincible. Once a fossil is removed without context, broken, displaced or lost, part of the story may be gone forever. The fossil itself is important, but so is where it was found, what layer it came from, what other fossils were near it, and how it fits into the wider site. This is why protected status is not merely ceremonial. Riversleigh was inscribed on the World Heritage List in 1994 as part of the Australian Fossil Mammal Sites, and it was included in Australia's National Heritage List in 2007. Those listings help recognise that the site has value beyond one local area. They also create responsibilities for management, research, education and protection. But legal protection is only one part of care. A place also needs respectful visitation, adequate research support, good collections management, collaboration with traditional owners, and public understanding. A fossil site can be famous and still underappreciated. It can be protected on paper and still need careful attention on the ground. The cultural setting matters here too. Riversleigh lies in Wani country, and current research priorities for the area emphasise the importance of recognising Wani cultural values alongside the scientific values of the fossil deposits. The same research priorities document notes that the Wani people are custodians of the cultural heritage of Budjamala, including Riversleigh, and that research priorities for the National Park and World Heritage Area are entwined. This is important because the land is not only a scientific archive, it is country. It has living meaning, cultural memory, and responsibilities that do not begin or end with fossil excavation. A better understanding of Riversley today means holding both truths together. It is one of the great fossil records of life on Earth, and it is part of a living cultural landscape. That should change the tone of how we talk about discovery. It is easy to say, they found a lost world, and imagine science arriving as the first meaningful attention the place ever received. But landscapes have histories of human relationship as well as geological history. Scientific recognition is one form of knowing, not the only form. The fossils reveal ancient biological worlds, while one ye connection to country belongs to a different but equally important order of meaning. Respecting both does not weaken the science. It strengthens the way we understand the place. A landscape can hold fossils, stories, lore, memory, research, management, and identity all at once. It does not need to be simplified for our convenience. Riversley also matters because it reminds us that the world is older, stranger, and more changeable than daily life suggests. Most of our routines encourage very short thinking. We plan tomorrow, next week, next month. We worry about a bill, a message, an appointment, a deadline, or whether there is enough milk for the morning, which often feels like a crisis out of all proportion to the amount of milk involved. Deep time stretches that frame. It does not make ordinary life meaningless, but it places it inside a much larger sequence. The limestone at Riversleigh holds records from tens of millions of years ago. The animals there lived in forests that vanished before humans existed. Their remains were preserved before our species had language, tools, cities, or the habit of checking phones in the dark. That scale can make the present feel both small and precious. The preciousness is important. Sometimes deep time can be misunderstood as a reason for indifference. If everything changes eventually, why worry? If species have gone extinct before, why care about extinctions now? Riversleigh gives the opposite lesson. It shows how much is lost when a world disappears. Not just animals, but relationships. Not just species names, but ways of living. A marsupial lion was not merely a body with cutting teeth. It was part of a food web. A small rainforest koala was not only an early relative of a modern animal. It belonged to trees, leaves, climate, predators, parasites, young, shelter, and night sounds. When a world changes beyond recognition, all those relationships are rearranged or erased. Fossils help us see the richness of what was lost, and that can make us more careful with what remains. There is also humility in Riversleigh. Modern humans are very good at behaving as though the current world is the main one, the completed one, the one that explains all previous versions. Fossils quietly disagree. They show that the present is temporary. The animals alive today are not the final addition. The landscapes around us are not permanent. Even the most familiar ecosystems are passing arrangements built from older histories and vulnerable to future change. This does not mean everything is fragile in the same way, or that nothing can endure. Crocodilian lineages have endured astonishing spans of time. Bats have diversified and persisted. Some marsupial groups survived major environmental shifts, but endurance is not guaranteed. The fact that some lineages survive should not distract us from the many that did not. Riversley's value also lies in its power to teach science as a process rather than a list of facts. The site is not fully known. Many fossils remain undescribed. New techniques continue to change what can be learned from old specimens. CT scanning, improved dating, digital modelling, geochemical analysis, and careful comparison can all open new questions. A fossil collected years ago may still have work to do. The research priorities for Riversley include improving data collection, storage, 3D models of significant material, and tools needed to manage the site effectively. That is a useful reminder that science is not finished just because a place has become famous. Fame can even create the illusion that the main discoveries are over, when in fact the archive is still being read. For young scientists, And for anyone who simply likes learning how the Earth works, Riversley is an invitation. It says that major discoveries can still be waiting in stone. It says that careful observation matters. It says that tiny fossils can transform large ideas. It says that the past is not dead material, but evidence that continues to affect how we understand the living world. In a culture that often rewards speed, Riversley rewards slowness. Fieldwork is slow, preparation is slow, description is slow. Geological time is extremely slow, to the point of showing off. But that slowness produces depth. A fast glance sees dry rock. A patient study sees rainforest, pools, caves, predators, bats, climate shifts, extinctions, and evolutionary history. There is something soothing in that patience, but also something demanding. Riversley asks us to think beyond the span of one life. Conservation often requires exactly that. Protecting a fossil site is not only for the people who visit it this year, it is for researchers not yet born, questions not yet asked, and techniques not yet invented. The same is true of living ecosystems. To protect a rainforest, wetland, reef, woodland, or grassland is to act on behalf of futures we will not personally see. That may sound grand, but it is also very practical. Someone protected museum specimens that later became important. Someone recorded field notes that later helped clarify a fossil's context. Someone preserved land that later yielded new scientific insight. Care accumulates, just as knowledge does. So why does this lost world still matter today? Because it shows that Australia's living animals have deep roots. Because it records how ecosystems respond to climate change. Because it protects evidence found nowhere else. Because it reminds us that extinction removes more than individual species. Because it connects scientific research with cultural responsibility. Because it teaches that landscapes can hold stories far older than the surface suggests. And because, in a time when living systems are again under pressure, it offers a long, clear example of the relationship between change and survival. The old Riversleigh rainforest will not return exactly as it was. Its animals will not step back from the limestone, shake off millions of years, and resume their evening routines beside the pools. The giant birds are gone. The marsupial lions are gone. The many ancient thylacines are gone. The small, strange mammals with their puzzling teeth are gone. But the meaning of that world has not vanished with them. It remains in the fossils, in the country, in the research, in the museums, in the protected landscape, and in the way the story changes anyone who takes the time to listen. A lost world can still do work in the present. It can deepen attention. It can sharpen responsibility. It can make the living world feel less ordinary and more inherited. And as we move toward the quiet end of this journey, that may be the most important feeling to carry with us. Riversley is not only about ancient Australia. It is about what remains when a world disappears and what those remains ask of the world that comes after. The stone holds the bones hold the memory. The memory, if we let it, can change how we look at the ground beneath us now, at the animals still living, at the habitat still breathing, and at the long unfinished story that continues quietly around us. And so, after walking through the old rainforest in our minds, after standing beside limestone pools, looking into caves, listening for bats, watching for crocodile eyes at the water's edge, and imagining animals that no longer have a living place in the world, we come to the quiet question that waits at the end of every fossil story. What remains when a world disappears? Not just one animal, not just one forest, not just one climate, but a whole arrangement of life. The trees that gave shade are gone. The pools are not the same pools. The creatures that climbed, browsed, hunted, called, nested, swam, and slipped through the undergrowth are gone too. The old Riversleigh rainforest did not move aside politely, so the modern landscape could take its place. It changed gradually, unevenly, under pressures too large for any animal inside it to understand. Rainfall patterns shifted, habitats opened, some lineages adapted, others declined, and some ended completely. There was no single final moment when the forest took one last breath and became history. It was slower than that, more ordinary than that, and in some ways more unsettling. A world can disappear by becoming a little less itself, generation after generation, until one day its pieces no longer fit together. That is one of the things Riversley teaches gently if we let it. Extinction is not always a thunderclap. Sometimes it is the loss of a habitat at the edge of a range. Sometimes it is a breeding population growing smaller. Sometimes it is a food source becoming less reliable, a wet place drying, a forest opening, a predator losing prey, or a specialist finding that the world it was built for has become just slightly less available with every passing season. To the animals living through it, there was no word for climate change, no concept of geological transition, no sense that they belonged to an ancient fauna that would one day be studied by people wearing sun hats and carrying notebooks. They were simply trying to live. A small mammal searched for food. A giant bird moved through vegetation. A predator waited in cover. A bat hunted over water in the evening. A turtle slid into a pool. Each life was immediate and complete. None of them knew they were part of a vanishing world, and yet, not everything vanished. That is the strange comfort of Riversleigh. The old forest is gone, but it did not leave absolutely nothing. It left teeth, it left skulls, it left jaws with the shapes of diet still written in them. It left shells, bones, fragments and traces held in limestone. It left enough for scientists to say carefully, this animal lived here. This creature climbed. This one browsed. This one hunted. This one belonged near water. This one was part of a family that still has living descendants. This one belonged to a branch that ended. A whole rainforest cannot be put back together from fossils, not completely. We cannot recover the exact calls of the birds, the colour of every leaf, the smell of wet bark after rain, or the small daily movements that made the place alive. But the remains are enough to prove that the world was real. They are enough to resist complete forgetting. There is something quietly powerful about that. A fossil is not life, but it is not nothing. It is the shape left behind when life has gone. It is a message without intention. The animal did not choose to become evidence. The pool did not choose to become an archive. The cave did not know it was preserving a future scientific treasure. Still, through accident, chemistry, burial, mineralization and time, pieces of that world lasted. The land kept them. When people later found them, the silence became readable. That is why the remains of Riversleigh feel different from ordinary stones. They are not only old objects, they are proof that the present is not the only version of Earth that has mattered. The modern landscape around Riversleigh can seem open and dry compared with the ancient forest it remembers. This contrast is one of the reasons the site stays in the imagination. You stand in one place and understand that it has worn more than one life. The ground beneath you has been rainforest, waterway, cave system, fossil bed, cultural landscape, research site, protected heritage place, and part of a living country still carrying meaning today. A landscape is never only what it looks like at the surface. It has depth, and sometimes that depth is measured not in meters, but in millions of years. Riversley asks us to look at a dry outcrop and see shade, to look at stone and see animals, to look at absence and understand that something full once stood there. This can make the modern world feel different. A living forest no longer seems like just scenery. A wetland is not just a wet place. A patch of woodland is not just a background to human plans. Each is an arrangement of relationships that took time to form. Animals depend on plants. Plants depend on climate, soil, water, insects, fungi, and fire. Predators depend on prey. Small creatures depend on shelter so ordinary that we often fail to notice it. A hollow in a tree can be a nursery. A pool can be a hunting ground, a drinking place, a breeding site, and a future fossil trap all at once. When a habitat disappears, what is lost is not only space. It is a whole set of possible lives. Riversley makes that clear because it gives us the remains of those possibilities after they have already gone. It is tempting to think of the fossil record as a safe distance from responsibility. These animals vanished long before us. The marsupial lions of ancient Riversley did not disappear because of modern cities or roads or fences. The old rainforest did not change because someone forgot to recycle a bottle, though it is still a good idea not to leave bottles lying around, if only to avoid giving future archaeologists the wrong impression of us. Deep time extinction is part of Earth's history. Life has always changed. Species have always arisen and vanished. But that does not make loss meaningless. If anything, it shows us that the living world is more delicate in its arrangements than it can appear. Earth continues, yes. Life continues in some form. But particular worlds do not always continue. Particular animals do not always get another chance. Once a lineage is gone, it is gone from the living world, no matter how beautiful the fossil it leaves behind. The fossils of Riversleigh therefore sit in an interesting place between comfort and warning. They comfort because they show that disappearance does not always mean total erasure. They warn because they show that even rich, complex, successful ecosystems can change beyond recognition. A rainforest full of life can become a record in stone. A diverse family of predators can narrow, then end. Giant birds can step through a continent for millions of years and then leave only bones. Early relatives of familiar animals can branch, diversify and vanish, while only a few lines continue into the present. The world is resilient, but not in the simple way people sometimes mean. It does not preserve every species because we find them interesting. It does not maintain every habitat because it once worked well. It changes, and life must answer. Some answers succeed, many do not. For a listener at night, this may sound heavy, but it does not need to feel bleak. There is a calm honesty in it. We are not separate from deep time. We are living inside it. The same earth that made Riversleigh's rainforest also made the modern world. The same processes of change, adaptation, preservation and loss are still unfolding, though now humans have become one of the strongest forces shaping them. That gives us responsibility, but also perspective. We are not the first creatures to live through change, but we may be among the first able to study change across millions of years and understand something of what it means. That is not a small gift. It is also not a small obligation. Riversleigh matters because it slows down our sense of importance in a useful way. Human life moves quickly. News arrives. Messages pile up. Plans change. We measure our days in meetings, meals, errands, and the small mysteries of household objects that vanish precisely when needed. A fossil site works on a different scale. It tells us that a jaw can wait in limestone longer than mountains take to weather. It tells us that a world can disappear and still shape knowledge millions of years later. It tells us that our present worries are real, but they are not the whole story. There is relief in that if handled gently. Deep time does not erase the day. It makes room around it, and perhaps that is why fossil stories are so well suited to the quiet hours. They do not demand that we solve everything tonight. They simply ask us to notice that the land beneath us has history, to notice that living animals are the latest pages of very old stories, to notice that extinction is not only a word from textbooks, but a change in the fabric of life, to notice that even a dry stone can contain evidence of shade. When the mind is tired, there can be peace in paying attention to something so much older than ourselves. Not because it makes us unimportant, but because it places us inside a wider order of things. If we return once more to the ancient Riversleigh forest, we can let the scene move slowly. There is warm air under the canopy. Water gathers in a limestone pool. Insects hover. A bat turns sharply over the surface. A small mammal climbs through branches, placing each foot with care. A browser feeds on soft leaves. Somewhere near the edge of the water, a crocodilian waits. A marsupial predator moves through cover, neither cruel nor dramatic, simply hungry. A giant bird steps into an opening and lowers its head to feed. Frogs call from damp places. The forest is not thinking of the future. It is not preparing to become a lesson. It is only alive. That is enough. Then time passes. Not a little time, but the great unfriendly amount that makes ordinary clocks seem almost comic. Bodies die. Bones enter pools and caves. Minerals gather. Forests shift. The old habitat changes. Some animals vanish from the record. Others continue in altered forms. Australia grows drier in many places. The land that once held that rainforest becomes something else. Much later, people arrive and find the stone full of clues. They carry blocks away, prepare fossils, compare teeth, name species, argue over relationships, revise ideas, and slowly bring the lost world back into knowledge. The animals do not return, but they are remembered more clearly. That memory now belongs to all of us, in a way. Not in the sense that we own it, because a place like Riversleigh is not simply an object to own. It is country. It is protected land. It is a scientific archive. It is part of a living cultural landscape. It belongs to responsibilities older and wider than any one visitor, researcher, or storyteller. But its lesson can be shared. Its evidence can change how we think. Its lost world can help us look more carefully at the living one. That is a meaningful kind of survival for creatures that have no living bodies left. There is also a humility in knowing how much remains unknown. Riversleigh has revealed a great deal, but not everything. Many fossils are still being studied. Some species are known from fragments. Some deposits may hold material not yet described. Some relationships remain uncertain. The old forest still has shadows. That is not a failure of science. It is part of the invitation. A complete answer would close the door. Riversleigh keeps it slightly open. It reminds us that the Earth is not finished being understood. Even after decades of work, a small bone in limestone can still change a story. This ongoing uncertainty is one of the most honest parts of paleontology. Scientists do not stand above deep time with perfect knowledge. They work with what remains. They make careful inferences, revise them when needed, and accept that evidence comes unevenly. That is very different from guessing. It is disciplined imagination, held in place by bone, rock, chemistry, and comparison. To reconstruct Riversleigh is not to invent a lost world. It is to listen to the remains and let them set the limits of the story. That is why the result feels so rich. It is not fantasy. It is reality seen through fragments. And what remains, finally, when a world disappears? Remains remain, of course. The word answers itself, a little too neatly, like a student who has been waiting all lesson to raise their hand. Bones remain. Teeth remain. Limestone remains. Scientific names remain. Museum drawers remain. Field notes remain. Protected landscapes remain. Cultural connections remain. Lessons remain. But something else remains too. The changed attention of those who learn the story. Once you understand that Riversleigh was once a rainforest world, filled with animals unlike anything alive today, a plain rock is no longer always plain. A living animal is no longer only itself. A landscape is no longer only scenery. The world gains depth. That may be the quietest gift Riversleigh gives. It does not shout for wonder, it waits for it. It lets the evidence do the work. A tiny tooth says that a small animal once fed there. A skull says that a strange hunter once moved through the forest. A bat bone says that night air once flickered with wings. A shell says that water once held life. Together, they say that a vanished world was once ordinary to those who lived inside it, and that our ordinary world may one day be known by what we leave behind. So as we come gently toward the end of this journey, maybe take one slow breath and think of where you are right now. The room around you, the light from your screen, the sounds outside, the time of night or day in your corner of the world. beneath every modern moment, there are older ones. Beneath cities, forests, farms, roads, bedrooms, and quiet streets, there is deep time. Not always visible, not always preserved as generously as at Riversley, but they're all the same. The Earth has been many worlds before this one, and it will be many worlds after. If tonight's walk through ancient Riversley has brought you a little calm, a little wonder, or simply a softer place for your thoughts to rest, I'd be very grateful if you liked the video and subscribed. It helps this quiet corner of Earth science reach other listeners who might also enjoy wandering through lost worlds without needing to pack a bag, check the weather, or worry about whether a tree-climbing crocodile is taking an interest in them. And if you feel like sharing, tell me where you are listening from tonight, and what kind of ancient place you would most like to visit if time and safety were not a concern. A rainforest full of marsupial lions might be fascinating, though perhaps best viewed from a very sturdy observation platform with excellent railings. For now, let Riversleigh settle back into the stone. Let the old pools grow still, let the bats vanish into evening air, let the great birds move away through the trees. Let the hidden predators remain only shadows, and let the limestone keep its patient watch. The lost world is not alive in the old way anymore, but it is not entirely gone. It remains in the ground, in the science, in the care of the land, and now, for a little while, in your imagination. Sleep well, fellow traveller, wherever you are in this brief modern moment, on a planet that remembers far more than it says aloud.